Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning about Java and Kotlin programming languages. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So, if you're a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without further ado, let's get started with the agenda for today's session. So first, we will begin with Java programming languages. In that, we will have a quick introduction to Java. Then we will understand the Java developer skills, responsibilities, roles, and salary. Then we will understand the Java developer job opportunities. Later, followed by that, we have the operators in Java. Then we have the operators in Java, that is the arithmetic operators, unary operators, comparison operators, bitwise, and followed by that, we have loops in Java where we will understand do-while loop, while loop, for loop. Later, we will understand the enhanced for loop, nested for loop, and then we have the access modifiers in Java. Once we are done with the access modifiers, we will learn about the OOPS concepts in Java, starting with encapsulation. Then we have abstraction. Later, we'll learn inheritance, then interface in Java. Once we are done with it, we will enter the polymorphism in Java, where we will understand the method overloading and method overriding. Once we are done with the object-oriented programming paradigms in Java, we will learn exception handling in Java. Once we are done with exception handling, we will get into collections in Java, where we will learn about array list, linked list, hash set in Java, tree set in Java, map in Java, hash map in Java, tree map in Java. And then once we are done with the collections in Java, we will get started with servlets in Java. And then we will learn some advanced programming paradigms in Java. Later, we will get through the Java interview questions, where we will learn some most frequently asked Java-based programming questions. Once we are done with Java, we will get started with Kotlin. In Kotlin, we will begin with understanding a brief introduction to Kotlin. Then we will start the Kotlin tutorial, and in that, we will learn about if-else statements, loops in Kotlin, Kotlin functions, Kotlin manipulations, Kotlin coroutines, and finally, Kotlin Jetpack tutorial. So this will be our agenda for today's session. I hope the agenda was clear. Now without further ado, let's get started with our first concept. Over to our training experts.
Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, servlets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to Bytecode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. Each button on the remote performs a different task. Methods in Java are the same. We can have methods to add two numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in 2 different places where their tasks will differ.
So what is Java? It is a fast, reliable, and secure programming language that can be used in several websites and applications. It can be used to create applications in a single computer or one that could be distributed across several servers and clients. Java can be used in several scenarios, independent of the system that it is used on. So let's look into what Java Development Kit means. All the Java applications and applets are developed using the Java Development Kit, that is JDK. Now, the JDK consists of the Java runtime environment, an interpreter, a compiler, an archiver, and a document generator, and a few more tools that go into developing a Java program. So now, let us have a look at the components of JDK. Java Runtime Environment, JRE, primarily is a part of JDK, and it can also be termed as Java RTE. The JDK provides the minimal amount of requirements needed to write and compile a Java program. JRE consists of the JVM, supporting files, and the core classes. The JVM is key to both JDK and the JRE because it is embedded into them. Now, whichever Java program is being run, the JVM is that component of Java that executes a program line by line, thus giving itself the work of an interpreter. We are now in a position to deep dive into the process with which JDK, JRE, and JVM work. Let's take a source file and save it with the extension .java. This file is compiled and converted into a set of bytecode which changes the file extension into .class. This is done specifically by the JDK. Now, here are the steps that follow. Class loader. It makes sure that all the necessary classes are loaded in the time of the execution of a program. Next, Bytecode Verifier, that is JVM. The Bytecode Verifier checks the code for errors or irregularities based on access rights on objects or implementation of pointers. It makes sure that the code fulfills the specifications of JVM and does not break the system integrity. And finally, interpreter, which is JVM. Now, while running the program, the interpreter loads, checks, and runs the code. The implementation is made by the JRE, which is the final process. The latest release is JDK 9 and it was released in October 2017. but it was in JDK 8 that a new feature called the Java Lambda expression was introduced that changed the face of Java. Now, Java Lambda expression is a kind of function which does not need any class to be created. It has been included in the latest version of JDK as it provides a clear, concise way to pass functions around. This also replaces earlier bulky anonymous classes and reduces code verbosity, that is, the length of the code. The syntax for the Lambda expression is this: argument list, arrow token, body. Now the syntax consists of three components, which are argument list. This can be empty or non-empty. Next, the arrow token. Now this is used to link argument to body. And finally, body. This contains the statement that works with the function. Let us now just see an example of using Lambda expression and contrasting it with how code would have been written with anonymous classes. This is the old method, and this is the new method with Lambda expression. Just have a look at how Lambda expression syntax has been used over here. The JDK 9 has been released recently and it seems promising with respect to new features and abilities. Here are some of the features. The first one is Java Platform Module System. This module allows strong encapsulation and declare explicit dependencies. Next, JShell. With the help of JShell, one can directly start writing the code on the console and execute them. Improved Java Doc. Java docs have got the search right in the API documentation, and as an added bonus, the output is also compliant to HTML5. Next, Stream API. The Stream API, also introduced in Java 8, allows programmers to easily parallelize code for improved concurrency and introduces functional programming abilities to the language. The Stream API, in conjunction with Lambda expressions, also comes in handy while iterating, filtering, and extracting large amount of data. The release of multi-jar makes it possible for codes to be run on the newer versions of JDK to be released.
Welcome to this video where we'll be telling you how you can install Java on your Windows 10 operating system. After we're done with this installation, we'll also show you how you can run a very simple program. So now let's get started. So now let's download Java. Let's go to Google and search for Java download. We'll go to the link we see here, oracle.com. So now here we have the web page. Here we can see Java SE 13. So this is version 13, but this isn't the one we are going to download. We're going to download the 8th version, version 8, which is here. Now we're doing this because 8 is one of the more commonly used versions of Java. So let's click this, and here we'll go down. We need to accept the license agreement before we can download it. Now we have two versions here, x86 and x64. Now you can download it depending on what version your operating system is. Now if you do have a Windows 10 operating system, it's highly likely you have a 64-bit version of Windows. Now if you do have a 32-bit version of Windows, you can take the x86. So let's download this. So we've actually already logged in, so we just need to run the installer file now. Let's go to downloads and run the file. So here we have the installer. We'll go to the next step. We'll select this to next. Here we can see where the file is being installed to. We'll go to next. Now if you want to change where you want to install Java, we can press the change option. I'm just going to keep it here. We'll press next and let's commence with the installation. And there we go. The installation is now complete. So we don't need any tutorials or API documentation. So we'll just finish off and go to close. Now to see if Java is installed in your system, we can go to command prompt and type the term javac, which refers to the Java compiler. Now as you can see here, this shows a number of different options you can choose from. This also indicates that Java has been successfully installed in your system. Now if the installation was not successful, you'll see something like javac is not recognized as an internal or external command, operable program or batch file. But since we've done it successfully, this is what will be shown. Now we're going to set an environment variable. Now what exactly is an environment variable? Now assume you have a file which has a .java extension. This environment variable tells the computer that the Java program needs to be called to run this particular file. So to set the environment variable, we'll need to go to Control Panel. Here go into System and Security. Go to System and select Advanced System Settings. And then this shows up. Now before we go into environment variables, we'll need to go to where the Java file was installed. So let's go to this PC, C drive, Program Files, and here let's go to Java. So let's go to JDK, which is the Java Development Kit. Let's go to bin here and copy this path. We'll go back to environment variables, select path here, and then press on new, paste this, and OK. Now we'll go back and go to JRE, to the path of JRE, which is Java Runtime Environment. We click on this, bin again, and copy this path. Select this one, new, and paste that. And there we go, the environment variables are now set. Now let's talk about running that simple program I told you about. Now this is possible with the help of an IDE. An IDE, or Integrated Development Environment, will give us a platform to code Java. We will be using Eclipse and Intellij as they are popular and commonly used. That being said, there are several other IDEs that are available in the market. So now let's work with Eclipse. Let's go to Google and search for Eclipse. We'll go to this link, press download. And then this shows up. Let's click on download. Now we've already downloaded the software, so I'm just going to directly go into the install phase. Downloads and select Eclipse. With this, you can see that there are multiple options for you to choose from. So we're going to select Eclipse IDE for Java developers. Now you have other options like for C and C++, JavaScript, PHP, and so on. But let's go to the first one. And here you have the details. You can change them if you want. But I'm just going to go ahead with installation now. Press accept now. Here we remember accepted licenses and press accept. And then here as well, we'll remember accepted certificates. Select this one and accept selected. And there you go, the installation is now complete. Let's click on launch now. So here we are setting up a directory as a workspace. I'm not changing it here, so I'm just going to go with launch. Here we have the Eclipse workspace. Now let's close this first. And here we have the package explorer. Now in case this doesn't show up, you can go to window, show view, and select on package explorer. So now let's go to file, new, and Java project. We need to set up a project name. I'm going to call it my project 1. Go to next. We'll go to source. So this is where the source code for your program is going to be stored. Then let's finish. And now we'll click on my project 1, go to source, right click, new, and create a class. I'll name the class my class and create it. And here we have it. So now let's write a simple program to multiply two numbers. So now let's write the main function. Open bracket. Now we're going to initialize the first number. Now the second one. And finally the output. And finally the variable that will store the output. Now we'll just give them a simple print statement. Now let's run the code by clicking this option here, using myclass.java, and there we have it. Here the product is shown to be 100, indicating that the program is running successfully. Now we're done with Eclipse. Now let's move on to the other IDE I was talking about, which is Intellij. So for that, again, we'll have to go back to Google so that we can download it. Search for Intellij download, go to this link here. So here you can see that we have two options, the Ultimate Edition and the Community version. Now here the ultimate version has way more options, as you can see here, but it's a paid version and only has a free trial. Now the community version is free, so that's what we're going to take. So we'll click on download here. So I've already downloaded the software, so I don't need to do it again. So I'm going to go to downloads, and so here we go. Let's just click on next. Select the location where you want to install it. Press next. Now we will add a 64-bit launcher shortcut on the desktop and create associations. So basically this means that these are the different file extensions that this will support. So .java, .groovy. And now let's go to the next step. We'll install now and we'll wait. And there we go. The installation is now complete. Let's not import any settings. We'll accept the privacy policy. We'll set defaults. Now let's create a new project. So here make sure your project SDK is set to the version of Java you've installed. Make sure this isn't blank. We'll go to next. Here you need to select this option, which is the create project from template. And we are now going to create a command line application. Press next. Name the project, which I'm going to call my project 2. You can change the location if you want. I'm just going to keep it the way it is, and then click on finish. So now we're going to create a simple program through which, based on the user's input, we can determine whether a number is even or odd. So first we're going to import the package scanner through which we can take the user's input. Next, let's go inside here. Let's create the variable reader. Now let's ask for the user's input. Enter a number. We're taking in the value now in the variable num. Reader dot next int. So this is with which we'll be taking in the value from the user. So we're going to set up a condition to determine whether the number is even or not. So if the number when divided by 2 provides the remainder 0, it indicates that it's an even number. We'll show them then. Now for the else case, the number is not even. Or in this case, odd. There we go. We're done. So let's run this program. So let's enter 12. The number is even. And there we go. We have a successful output. This indicates that the program is running successfully. An IDE is an integrated development environment. On this, computer programmers can perform software development. Now, Eclipse is one of several in the market like Intellij, BlueJ, Dr. Java, and so on. Now, to install Eclipse, first you need to install Java. This is because if you try to run the Eclipse installer, this shows up. This shows that you do need Java before you can install Eclipse on your operating system. So first let's go and download Java. Now let's search for Java install and then go to this link. Now here we have the latest version, which is version 13. We're not going to pick that one up. We're going to go to version 8. Now we're choosing version 8 because this is one of the most commonly used versions of Java. So let's select this. So we'll go down all the way here. And here we can see two options, the 64-bit and the 86-bit. So this basically represents the 32-bit operating system. So if you do have one, you can select this option. Since we have a 64-bit operating system, I'm going to select this. But before the installation, you need to accept license agreement and select this. Now I've already logged in, so I'm just going to install now. Let's select this, go to downloads, click on this. And then this shows up. We'll go to next, and let the install complete. So here we have another pop-up. So if you want to change the destination folder, you can select this option. This is fine with me, so I'm going to go with next. That's it. We'll let the installation complete now. So there you go, the installation is now complete. So if you want to look at tutorials or documentation, you can go to the next steps. I don't want to, so let's close and go back. Now just because we've installed Java, we can't exactly run it yet. For that we need environment variables. Now environment variables help the computer understand that it needs to run Java when it sees a .java file. For that, let's go to the control panel. Let's go to system and then let's go here and select advanced system settings. And then this shows up. Now before we can set the environment variables, we'll need the path to where Java is installed. So let's go to File Explorer. Let's click C drive. Let's go to Program Files. So this is where I install Java. Let's go to Java. First, let's go to JDK and bin. Now let's go back here. Click on environment variables. Select a path here. Now go back. Let's copy that and press on new and paste this. Now likewise, let's go back. Go to JRE, which is the Java runtime environment, and JDK, which is the Java development kit. Click on this, go to bin and select this path. Go back, go to path, select new and paste this as well. And there you go, the environment variables are now set. Let's click on OK and that's done. Now let's install Eclipse. Let's go back again and search for Eclipse. In here, select this option, click on download, select 64-bit. So and this shows up. So I've already downloaded it, so we can directly go there. I'm going to click on this now. So now we have the installer show up. So here you can choose from a number of different options like C, C++, PHP and so on. So you want this one, we'll click on this and here we can just install. We'll accept and there you go, the installation is going on right now. We'll remember accepted licenses, accept this. You need to accept these certificates, accept selected. And there you go, we're complete. Let's launch. So now we need to set up a directory. So I'm okay with this. So let's launch. And there you go, here's the workspace. So let's run a very simple program now. So we'll close this and here you have the package explorer. Let's open this up. So in case you can't access the package explorer, go to window, click on show view and select package explorer. Now first, to run a program, you need to create a Java project. Click on this and let's name our project. Let's go to next. And here you see src or source. Now this is where the source code of your program is. Now we'll just finish and that's that. Now we go to source. Right click, new and create class. Now let's create a class 1 and finish. And now we should be able to run any program we want. Let's look at the very simple code of writing hello world. So let's open the main function. There we go, let's open a bracket. Here, let's print. And that's that. Now let's run the program by clicking on this icon. Let's select the class. And there we go, we have an output. This means the program is running successfully.
Let's begin with the fundamentals. So the first one in the fundamentals is the data types. So every programming language has a data type. So what exactly is a data type? So whatever the input you provide in your program is a data type. For example, if you provide numbers, so in that particular numbers, we have a different variety of numbers. If you are giving just 1, 2, 3, so on without a decimal number, then that particular type of input, which is a number, will be considered as integer type. If you provide the same number with a decimal point, then that will be considered as float. And if you have the range greater than float, it will be considered as double, and so on. So this is how we have multiple data types in every programming language. So the most frequently used data types in Java programming languages are as follows. At first we have the byte, followed by that we have short, int, long, next float, then double, boolean, and finally char. Apart from this, we also have few other data types, but these are the most frequently used ones for all the basic programmings. So this is made for beginners basically. So you can take a quick screenshot of this particular slide so that you can have a quick overview or reference to all the data types in Java programming language. So I hope you have taken a screenshot of this. Now let's begin with the next concept. So in the next concept, we have the keywords and variables. So all the programming languages have variables and keywords. So variables are used to store the values. So for example, consider that you wanted to run some arithmetic operation on two different values, that is 5 and 10. So in order to do so, you might want to create a variable which stores them. For example, you wanted to store the value of 10 in a certain variable A and the 5 in a certain variable B. So if you apply the arithmetic operation, that is a is equals to a plus b, then the value of a, which was previously 10, will be updated to 15. So here you can see the value is varying, and also it is storing the result. So this is why the variables are used in a program, in order to store a value, and this particular term variable is used because the value can change at any instance of time once after a certain arithmetic or a logical operation is performed on that particular variable. So similarly, we have keywords. Unlike variables, keywords have a special meaning. No matter whatever you try, you cannot change the meaning of that keyword. For example, consider main. So you cannot use the term main for normal things because the part or the term main is dedicated for a different purpose. So whenever you try to execute your Java program, the control flow will start executing the program right when it reaches the term main. So it has a special meaning. Similarly, you have other keywords such as int, so that is dedicated for integer type of values, and float for float type of values, that is the decimal values, and byte for byte, char for character type data, string for string. So every keyword or every term with special meaning which is predefined and cannot be changed is called as a keyword. Now let's see the most frequently used keywords in Java programming language. So similar to the previous one, we have a table here. So in this particular table, we have the most frequently used keywords in Java. So you can see we have boolean, final, byte, native, and we have void, switch. So switch is a conditional statement. So we have if it is also a conditional statement. We will go through these conditional statements as we proceed in our tutorial. And you can also see the protected. So this term, which is protected, public, so this is basically the access modifier. Even this particular keyword have special meaning. This public, this protected keywords provide the information to the compiler or the interpreter about the accessibility of that particular data member or data manipulating method. So if it is protected from your accessibility or is it available for you, it's provided by these keywords. So we will deal with access modifiers in the upcoming parts, don't worry about that. And as you can see, we have implements, extends. So extends, this term comes in inheritance. So inheritance is one of the crucial concepts of object-oriented programming. You can also see abstraction. So this we will be dealing in the next upcoming part, where we will understand the object-oriented programming concepts. Next we have interface, return, and so on. You can also see some keywords like throw. So throw will come in exception handling. So we will also learn about exception handling in the upcoming part. So these are the most frequently used keywords in Java. So now we will move ahead into our next concept. So the next concept is the operators in Java. So to understand operators, let's go through a table. So on my screen, you can see a table which has some arithmetic operators which are most commonly used. That is the plus for addition, minus for subtraction. Similarly, we have star, forward slash, double plus, double minus. So double plus and double minus, say they are increment and decrement operators respectively. As you can see, we have a plus plus here, which means the post increment. So the first value will be read, after that the value will be updated. Next we have the pre-increment, the value will be incremented first, then the updated value will be stored. So that's how the increment and decrement operators work. So we have the modulus over here. So to understand the operators that we use in Java in a much better way, let's try to execute a sample program. So on my screen you can see a program which is based on operators. So we are currently on the Eclipse IDE. Don't worry about the IDEs in Java, etc, etc. So I will drop a link in the description box below which will explain you in a very detailed way about how to install Java into your local system and how to install Eclipse IDE in your local system, and also how to create your first project, how to create your package, how to create a new class, how to write your program and how to run that, how to see the output, and a complete overview of the Eclipse IDE, how that works. So everything will be linked in the description box below. You don't have to worry about that. So right now, to save time, I have created the text document which has all the programs that we will be executing today. So I will also drop a link for that particular file so that you can have complete access to that file so that you can run the programs in your personal PCs or laptops and also understand the programs in a much better way. So now let's begin with the program. So this particular program is basically designed for arithmetic operations. So you can see we have the operators, that is the addition, subtraction, multiplication, division, modulus, and exit. So basically we will be taking input from you. So the input will be taken by the user. That is, we are using scanner class here. So scanner class takes the input from user, and that particular input will be compared here. So we are using the switch case here. So if you provide the option as 1, then addition operation will be run. Similarly, second for subtraction, third for multiplication, fourth for division, fifth for modulus, and sixth to exit. So this is how the loop or the program works for arithmetic operations. Now let's quickly run this program and see the output. So you can see the program got successfully executed and we have the console asking for the first input. Let's provide some random number. Now let's provide the second number. So there you go, we have our options over here. Now let's choose division operation. For that we need to provide the number 4. So there you go, we have the result over here, which is 4. Now the loop has started once again. Now it's in the starting stage again. It's asking for numbers. Now let's provide 25 and 5. Now let's choose some operation, that is addition. So for that you need to provide 1. So we have the result again, that is 30. Now let's again choose some number, 10, 5. So basically that's how the program works. So we have the brief idea how the program is running now. So now let's quickly continue with our next topic. Now to terminate this loop, you can provide the option number 6. So we have terminated it. So I hope you understood how the program flow is running. So if you did not understand, don't worry. I have linked the document in the description box below. You can take the access of that particular document and you can check the program and run in your local system, and also you can make some modifications to it. As you can see, we don't have a default case over here. I've just placed the case 1 to 6 and I'm saying the default because you can see that the options are from 1 to 6. What if the user provides the number as 7? Right? So the program might crash over here. So for that purpose, you can write in another case that would be the default case. So the default case will check if the number is anything above or out of the range of 1 to 6, then it should be providing you with an output saying a wrong input has been given or check your input or something similar. So that's how you can make some modifications to it. You're free to modify the code as well. Don't worry about that. So now let's quickly begin with our next concept. So in the next concept, we have the conditional statements. So what are the conditional statements or the control statements? So basically these are these are conditions. So what happens is, just imagine that you wanted to do something, or if you wanted to drive a vehicle, or if you wanted to drive a bike. So the condition you will apply on your mind is, if I know driving, then I will do it. If not, I'll not do it. So that's what you do, right? So basically you apply a condition on your mind and you do it if it is capable of doing, or if you are capable of doing it. So in the same way, the conditional statements play a major role in computer logic. So before writing a code or before you start your program, you provide the condition. Perform this particular operation if the provided condition is satisfied. So similarly, you have these 3 conditional statements in Java, which are if else, and nested if. So we use these conditional statements in Java to implement our logic. So we will understand the conditional statements, particularly if else, and nested if, in a much more detailed way by practically running some programs based on these 3 types of conditional statements. So now you can see that we are back on the Eclipse right now. So this particular code segment is based on the if condition. I hope the program is visible. Let's try to increase the font size. So I think it's better now. So basically we have an input. So we have the integer type of input, that is num, and we have the number as -100. So it is a negative number. And after that we have the if condition. So this is where the conditional statement is provided. So the condition is, if the number is greater than 0. If the provided number is greater than 0, then the control should enter the loop, which is this particular segment, and execute the statements present inside that particular loop. So here we have one single statement, that is a print statement that says the number is positive. In case the condition fails, imagine that the condition fails, then what happens is that instead of entering this particular code segment, the control will skip and execute the next statement, that is another printf statement which we have over here, which says the if condition is terminated, control is outside the condition block. Now since we have provided a negative number, the second option should go ahead. Now let's try to run this and see the output. So there you go. As expected, the program got executed and we have only one statement, that is if condition is terminated, control is outside the block. Now let's try it otherwise. Let's just eliminate the negative number and now check it again. There you go. Now you can see the program got executed and now we have two print statements. You can see that the condition here was true, so the control entered into the statement or the code block and this particular statement got executed successfully. Once the statements are executed and there is nothing else to do, then the control will automatically exit this particular statement and it will enter into the next statement, which is another printf statement, and we have the same output over there. So this is how the single if statement works. So you can also modify this with an else. So that's the next program that we are going to see. We are going to execute some similar kind of example for our next kind of conditional statement, that is if else. So here only we had one if condition. So in case if this particular condition fails, then we will be having another condition over here, which will be the else block. So as you can see, we have another program. So this particular program is based on if else condition. So here you can see that we have our first if condition, which states number should be greater than or equals to 0. If this particular condition is true, then this statement should be executed, which says the number is positive. Else, if this condition fails, then what you must do? The control should avoid entering this particular segment and it should directly hit the next segment where we have the else block, which has another statement which says the number is negative. So this is how the program works. So here we will be doing a little modification over there. Instead of taking an input which is previously defined as it was in the previous example where we had given -100 previously, we are going to do it a little differently. This time we'll be taking or reading the input directly from the user. So for that we are going to use this scanner class. So this is the particular library that we will be using. So we have imported java.util.scanner. So this particular code segment will ask you for the input and you will press some random number and it will read it as its input. Now let's try to quickly run this program and see the output. There you go. The program got successfully executed and now it is asking for an input from the user. Now let's try to provide a negative number. So there you go, the program got successfully executed and you can see that since we had given a negative number, the control did not enter this particular code segment at all. It directly avoided to enter this code segment and entered into the else block and executed the statements present in that particular else block, which was a simple print statement that had the statement which read as the number is negative. Now let's try to execute the same program again and see what would be the output. So there you go. Now it's asking for the input again. Now this time let's provide a positive number. So there you go. Since we provided the number as a positive number, this condition was true and this particular statement got executed. Since one of the statements executed, there was no need for the else block to be executed again. So you can see this particular code segment runs in this way. So once the condition is checked, so if the condition is true, then the true statement will be executed. In case if the condition's result is false, then the false statements will be executed. So you will be provided with two options. So one option for true validity and another option for false validity. So this is how the if-else block works. I hope you understood this. Now with this, let's continue with the next type of conditional statement, that is the Lzf Ladder. So on my screen you can see there is a change of program. We have stepped into the next type of conditional statement, that is the Lzf Ladder. So basically everything will be same. We will be provided with only one condition. So we will be checking the validity of that particular condition. So if the provided condition is true, then the first one will be executed. If it is not, then the second one will be executed. If the condition fails for the first two, the third one will be executed. If the first three fail, then the fourth. And if all the four fails, then we will have one last else which will print the last segment or statement. So this is how the Lzf Ladder works. So basically it's completely similar to if else, but the only difference is instead of one else block, we have multiple else blocks. That's the only difference. Now let's quickly execute this program and see the output. So basically we are going to take an input from the user. So we will be entering 1 for noodles, 2 for milkshake, 3 for fruits, 4 for coffee. So something like that. And if we provide anything else than 1, 2, 3, 4, then we will be having an else statement which says it's an invalid input. So the flow of this particular else if statement is similar to the switch statement. Having said that, we will also discuss something about switch statement as well. Basically we'll try to execute a program based on switch statement, and we'll also understand the control flow of that. Don't worry about it. Now let's quickly execute this particular program first. So there you go, the program got successfully executed. Now it's asking for an input. Let's select noodles. That's how it works. We have the output noodles. So the choice is equals to 1. So the first one was true. So it executed the first code segment, and everything else got suspended because this was not necessary to be executed because the condition was true over here, and according to that only this particular statement was supposed to be executed. So that's how it works. Now let's switch into the next conditional statement, which is the switch. So you can see that we have a program on my screen which is based on switch case. So you can see that there is some similarity between this particular program and the first program we dealt with, that is based on operators. So we also have the default code segment over here. So this was what I was talking about. You can add a default code segment in that particular program, which is the operators program, and do some modifications. So this is what the suggestion I gave over there. Now basically what happens in this particular code segment is, so we have Monday as the day 1 of a week, Tuesday as the day 2 of the week, and so on. So to select one particular day of a week, you need to provide an input. So it's based on 1, 2, 3, 4 and so on to 7. And if you provide anything else than 1 to 7, you will be provided with a message which says invalid input. So now let's try to run this program and see the output. So there you go, the program got successfully executed. Now let's select the weekend day. So which would be something between 6 and 7. So 6 is Saturday and 7 is Sunday. Let's go with 7. So there you go, Sunday. Now let's try to execute this program once again and give a wrong input and see if it works or not. Let's provide 8. There you go. The program identified it as a wrong input, so it gave us a message invalid input. So that's the use of default code segment in switch case. So you can implement this in that operators program and check out how it works. Can be considered as a homework though, not a problem. Now this is how the switch case works. So with this, let's move ahead into the next concept in our Java tutorial for today. So the next segment is about the loops. So what are loops? So conditional statements are some statements which get executed based on a condition if the condition is true. If not, then that particular condition will not be executed. Loops are a little different from conditional statements. How? So basically you will be provided with one single statement and you wanted to execute that one single statement for a particular number of times. So in that condition, instead of writing the same code segment for several number of times, you can just use a loop. For example, consider that you wanted to print numbers from 1 to 10. So the brute force method, or the simple or the first method that fires to your mind is write that print statement for 10 times. That is print 1, print 2, print 3 and so on to print 10. But what if you had to print 100 numbers? Okay, doable. You can write the same print statement for 100 times. But what if you had to print 1000 numbers? Imagine 1 billion. Can you do 1 billion print statements? No, right? So in that scenario, you can use loops. So you can just write one condition. Repeat this particular print statement for 1 billion times. Then the interpreter or the compiler will take care of that. So that's the reason why we use loops in Java. So basically we have 3 loops in every programming language. That is the for loop, while loop and do while loop. So a loop statement in Java execute a set of statements until a specific condition is satisfied. So here the 1 billion example. So here you will start from the 0th count. So that will be the counter variable which counts the number of repetitions, and followed by the counter variable you will be having the condition. So you will be having the counter variable I is less than or equal to the number 1 billion. So until that you have to print this particular statement. And followed by that you will be having the increment or decrement operator. In this case you need to use the increment operator. For the first time, once the print is done, you will increment the value to 2 and the loop will be iterated once again. So this will continue. The loop will iterate itself until 1, 2, 3, 4 so on, and until it reaches 1 billionth number. So that's when the condition fails. I is greater than or equal to 1 billion. So that's when the condition fails. The condition was to be I should be less than or equal to 1 billionth. So when the number increments above 1 billion, then the condition fails. So the condition was the number should be less than or equal to billion, but the number has exceeded the billion. So that's when the loop terminates and executes the next statement after the loop. So I think this was a little clear about the loop workflow. Now to understand the loops in a much more better way, let's execute an example for each one of these types of loops. So we have for loop, while loop and do while loop. Let's execute the programs for all of these 3. So you can see that we have a program on my screen. So this particular program is based on for loop. So you can see that the code part highlighted on my editor is the for loop. So you can see int I is equals to 1. So this is the counter variable. So I is the counter variable which stores a number from where the count should begin. So sometimes you can choose 0, sometimes 1, or the number of your choice. So here I've chosen the number 1. So after the initialization part, we have the condition part. So remember the 1 billionth example we discussed before? So here we have I should be less than or equal to 10. So this particular loop segment will run until the condition, that is I value should be less than or equal to 10, is satisfied. Once it turns false, the control will exit the for loop. So that's how it's designed to work with. Now followed by the condition we have the pre-increment operator. Once the condition is checked, the control will jump to the next statement, that is the pre-increment operator, and it increments the value of 1 to 2. So this is how the loop works. Now let's try to execute this program and see the output. There you go. The program got successfully executed and the output has been printed. So basically what was this statement to be executed? It was a printf statement looped plus. Here the plus symbol works as a concatenation operator. Here too. Now in between the printf statements we have the value of I. So in the first place I was equals to 1. Once the pre-increment was taken place, the value of I will be increased to 2. So there you go, you can see the number 2 over there. Now in the second iteration we print the value looped 2 times. Similarly in the third iteration looped 3 times. So that's how it works until the last iteration, that is looped 10 times. So once the condition is checked here, the control will enter into the next part where the pre-increment takes place. So the pre-increment increments the value of 10 to 11. Now the control will come back to the initialization part. Here we have the new value for I, that is 11. Now 11 will be checked against the condition. Is 11 less than or equal to 10? No, right? So the condition here fails. Now the loop is terminated. The control will exit the loop. So this is how the for loop works. Now let us also consider another example for for loop for a better understanding. So in this particular program, we are going to print the sum of n numbers. So in that particular n numbers, we will be having even numbers and odd numbers. For example, consider that you have provided the number as 5. So the numbers in between 0 to 5 or 1 to 5 are 1, 2, 3, 4 and 5. So the 4 is even number, and apart from 4, everything else are odd numbers. So odd numbers are the numbers which are divisible by 1 or itself. So now the sum of odd numbers is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11. So that's how you print the sum of odd numbers, and the sum of even numbers, that is only 4. So that's how the loop works here. You have the condition, if else condition, and out of that if else condition you have the for loop. So this particular loop should be running until a given number that will be given by you. So that's how the program works. Now let's quickly execute this program and see the output. So there you go, the program got successfully executed and now it's asking for an input. Let's check out 5 itself. Now you can see we have another program on my screen which is basically based on the same for loop. So here we have the for loop. We will be providing an input which is num, and inside that we have another condition, that is the if else loop. So basically if loop is dedicated to find out the even numbers and else loop is dedicated to find out the odd numbers. Now the whole motto of this particular program is to find the sum of even numbers and the sum of odd numbers between 0 to the input number which you provide. For example, consider if we provide the number 5 as the input, then in between 0 to 5 we have odd numbers and even numbers. So the even numbers are 2 and 4 and the odd numbers are 1, 3 and 5. So basically what happens here is we are going to add up the numbers. So the sum of even numbers, that is 2 and 4 is 6, and sum of odd numbers, that is 5 plus 3 is 8, 8 plus 1 is 9. So that's how it should work. Now let's quickly try to execute this program and see the output. So you can see the program got successfully executed and now it's asking for an input. Now let's enter 5 itself and see the output. So there you go. The sum of even numbers up to 5 is 6 and the sum of odd numbers up to 5 is 9. So this is how the program works. Now apart from for loop, we also have another way to declare the same for loop. So that particular type of for loop is called as the enhanced for loop, or in some cases it's also called as advanced for loop. Let's see how the for loop is declared in a different way. So instead of using the typical for loop which has the initialization state, then the condition, then the pre-increment or post-increment or decrement kind of operations, we simply have declared the for, and inside that we have int arr, which is the name of the variable of array type, and inside that we have the array. So our array consists of 10 numbers followed from 1 to 10, and now this particular loop will execute for 10 times or until all the values in the array are printed. So now let's try to print this. So there you go, the program got successfully executed and we have all our values from 1 to 10 which were the input or the saved part of the array. Now with this, let's continue with the next kind of loop, that happens to be the while loop. So you can see an example based on while loop on my screen. So basically everything is same. There is no much of a difference between for loop and while loop, but the only difference is the keyword. Instead of for, we have a while over here. So we have the while condition over here which says I should be less than or equal to num divided by 2, and if this condition is true, then the control should enter into the conditional statement if num modulus I is equals to 0, flag is equals to true, and break. So basically the whole motto of this program is to find out if the given particular number is a prime number or not. Now let's quickly try to run this program and see the output. Now you can see the program got successfully executed. Let us try to provide a prime number and see if the program could identify it correctly as a prime number or not. There you go. The prime number we provided was 5 and the program successfully identified it as a prime number. So that's how the while loop works. Now let's execute another program based on while loop, but this time we will place the condition at the end of the loop. So yeah, you guessed it right. This is do while loop. The only difference between while loop and do while loop is that before the condition is checked in while loop, no statement is executed. But it's completely opposite when it comes to do while loop. First, the program or the code segment will be completely executed. After that, the condition will be checked. Surprising, right? Let's check out the practical part. Yeah, we have our program on my screen right now. So in the previous program, we had the condition somewhere over here. That's the while condition. But here we have the do statement here. So what we are going to do is we are conveying the compiler or the interpreter to execute this particular statement first without checking the while condition. So this is the only difference between while loop and do while loop. So we have run the program successfully and it got executed, and we were supposed to actually print the values of I from 1 to 20, and they have printed over here. That's how it works.
So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using Intellij. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name and student's age. There we go. Now we have these three variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need two classes for this program. So I'm going to create two classes. First, I'm going to name it as bikes, and the second class, I'm going to name it as cars. So let's create variables for these classes. So in cars, first I need string, name, and I need the cost of the car. So cost can be integer as well. Because I'm going to use $sign in that, so I'm going to use string because of that. So same thing I'm going to do with bikes. Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer. So I'm going to use B1 till B5. and I'm going to name them from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars and let's name it as Lamborghini. Similarly, car 2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4, Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do it 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I am going to assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste. It will be a lot faster and easier to do. Car 2, car 3, car 4 and car 5. We don't need this. As per car 2, let's take it as 252,000 and let's make it as 3 million. As per this, let's keep it as 1,400,000 and lastly let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these values. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm going to ask which one would you like to choose. To enter the choice, I'm going to use one more variable. Let's say n. So I'm going to store n. If n is equal to 1, that means Harley Davidson, then I'm going to show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4 and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari, then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for Ecos. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is Shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1 And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm gonna enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry, and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student. And yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars. And then I'll create one more class with the name bikes. And then one more class, automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double, and let's say fuel. And then same thing, private, double, and then year. And let's take one more, private, string, and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm gonna start with the code now. It's a very simple code. First I'm gonna create the variables or the objects of the class with private bikes, bike. So one is car and one is bike. Both are objects for the classes. So I'm going to use these objects. Bikes, bike is equal to new bike. This is so that my object can function really well. And now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed. And the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm going to do with cars. Now how does a car start? With a key. So I'm going to make a function, public key. And inside it, I'm going to print the same message. Car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message. Car has been started with key rotation. Let's write that as well. So in the main program, I'm going to use objects to use those functions. And let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions. So if I execute it, these are the error messages that I'll get. Cannot find the symbol method kick or method key.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is, the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is, an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. For example, I have named my class as Simplilearn as shown here. Followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then, the return type of the method. As of now, I have used void. Then, later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So, this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So, interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java Project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select New, and inside New you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right-click on the package and select New, and inside that, let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the Employee class and gets executed to generate employee details. Now let us try to execute this program and see the output. To execute the program, just right-click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here, the class student is the abstract class, and three different student classes, namely Raju, Pranita, and Punit will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita, and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method which is interest. So we have the classes Andhra Bank, Bank of Baroda, IDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks has been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are: the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are: abstraction is expensive, as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is object relational impedance mismatch in the case of RDBMS, and the last disadvantage is object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
What is Java interface? An interface is a container that stores the signatures of the methods to be implemented in the code segment. It's really hard to define interface because it's the meta of meta. It's basically a control object. And so you see these in projects where whoever is in charge needs to have a very high level of control of what everybody else is doing. Do you have to have an interface when you're doing programming? No. But if you're in a large project, you probably want one as director, or if you're receiving it, you might get the interface which you're supposed to use in your programming. So when we talk about the need for interface in Java, it's a total abstraction, and it's only the methods. We're not talking about any variables or anything like that, just the methods. You can do multiple inheritance, so you can inherit from different interfaces, and you can do loose coupling. And when we talk about loose coupling, you can think of 100 programmers working on a huge software package, and they really don't know what the other programmers are doing. They can't meddle with it. They can't mess with it. They have like a nice direct place they can do, and they have the information they need in the interface. So we'll talk about the syntax of the Java interface. The interface, then you have your interface name, and then you declare your constant fields, declare your methods, default method. And really, to understand this, we just need to take a look at an example in Java interface. And we're going to do the Java interface defined area. Just kind of a fun little code. For this, I'm going to jump into Eclipse. And we'll go ahead and create a new package. There we go. And we'll call this interface. And we're going to go ahead and add in Java. It won't let you do just straight interface because that's a reserved word. We'll go ahead and create that. And then underneath our package interface Java, we want to go ahead and actually add in an interface. And so we go underneath here, new interface. And let's go ahead and call this one, we'll call it area, interface area, and finish. So now we have our package and we have our area, and this is just the same package we did with our polymorphism and inheritance. So now we have a package, and we've added the object of an interface. And note that the interface is always public. You never have a private interface because it's a meta file. So it's always going to be accessed by other people and by other classes. And as we're creating these methods, this works just like you would any other method. I could easily put integer, and then we have maybe integer side 1, integer side 2. So you can see how you can do, like for the setup, this is going to be just like you do the rest of your class and the rest of your methods. But we're going to keep it simple. And we're just going to do void square, and let's go ahead and do public void rectangle. We'll put a rectangle in there too. So now we have a basic interface, in this case for area. One of the cool things about interface is I can go in here to create another, let me go back into my interface Java, and we'll do another new, another interface, and we'll call this area curves. I don't know, just making that up. So we have our area curves, and maybe in this one happens to be for a circle. So we have our curved areas. Let me just go back in here. And maybe we'll do not only a circle, but an oval. There we go. So now we have our circle, oval, or eclipse, depending on what you want to use on here. And I can go back to my area. And just like you can in classes, this extends area curves. So now I can also do the extends, or in the case of inheritance, same as in a class. Exactly the same. It just makes it easier if you have a hierarchy of stuff coming down in your interface. Now we'll go back in here to the package. Oops. We're going to go back here and create a class, and let's go ahead and do that in here under our interface, new class, and we'll go ahead and call it shape area. And so now we have our new class shape area. how the heck do we use our inheritance area in here? Well, we just go ahead and do implements area. And so once we do that, we now have area, which happens to extend area under curves. And let's go back in here to our shapes area, the class. And what I want you to notice in Eclipse is the shape area has an underlined red. And if I hover my mouse for it, it's kind of hard to see here a little bit. I'll give you some options there, which will say, bring in your implements. You're implementing area, but you didn't do anything with it. That is what interfaces are all about. It's about forcing someone to show an error here. Now in Eclipse, I have it set so it won't throw an error if I run the program, but it's going to tag it. So even if I compile it right now, let me just go ahead and run this, even though it doesn't do anything, it still has the shape area underlined. And then it comes up here and also puts a little exclamation point at the top when I actually do some actual coding in here. Let me go ahead and do that so you can see what that looks like. There we go. We'll put in our main and we'll initiate our instance of shape area. And we'll go ahead and run this. Doesn't actually do anything. It's going to compile all our different pieces on here. And you still see the shape area is got the red light underneath of it. When it pops up, it says, hey, you have some unimplemented methods. Make type shape area abstract or different solutions on there. It's because we don't have the actual code. It's saying, hey, you were told to use what's in area and you're not using it. Again, this is all about being in control. And so we have in here, when we go back into area, oops, that's area curves. Let's go all the way to area. We have to have square and rectangle in there. And because this extends area curves, we also have to have circle and oval. And so when we put that in there, we have to do an override. Just so our package actually does something, let's go ahead and bring in the scanner utility. This is just capturing your keyboard. That's what that's for, the Java utility scanner. And then we're going to go ahead and do our override. Use the @ symbol, override. There we go. And then we go ahead and take a look at what we had in area. Well, in area we had square, so let's go ahead and grab the square. This, of course, is just being very lazy and not having to retype it. So we have our public void square. And then we wanted to do something in here. In this case, we want to go ahead and create a scanner for the keyboard. And we'll do a new scanner system in. And that's all that is we're going to do, we're creating an object so we can capture keyboard input and request information from people. And since this is a square, let's see. We're not going to get too caught up in the code here. Oops. There we go. And we'll go ahead and do geometry of a square and compile it and run it. It still lets me compile and run it. And you can see down here it actually says, hey, enter the length of the side of the square. We'll put in 5. And the area of the square is 25. So when we look at just this part, we have it accesses the square, prompts us for our input, does the math of the square, and is fully functional. But I want you to look up here. It still says, this still has an error. It still says, hey, you're missing the stuff in here. You don't have all the pieces you're supposed to have in here. So if we're missing the pieces in the implements of area, we need to go ahead and put those in. Now, we're not going to go through and do all the different areas and walk through each piece. But we're going to look at this. When I put in our rectangle, which is, we have the square and the rectangle, and then we had the circle and the oval, you can see that the error goes away. So I no longer have a shape area with an error on it. And if I run it, it of course will still compile. There we go. And if I come down here, forgot I got to put in something for the square. We could also, instead of square, just do whatever it is. You'll see that circle still functions, although it's just going to do a printout as opposed to what we had before, where it takes in all the information, computes the area. This is what implements is about. It's about taking all this stuff and pulling it in and forcing the programmer or the people in the team to use the different methods that they need for that particular class. And there's one more thing that we want to do, and I'm going to take this extends out here. And then we're going to go back to the shape area, and you're going to see it's going to give me another error on here, a slightly different error. And the reason is that I did overrides, but these don't exist, so they don't know what I'm overriding or what the setup is. And let's say instead of importing area, instead of having area inherit area curves, we could also just implement area and area curves. And then you'll see that the error then goes away when I run the compiler. There we go. And this should remind you of something we talked about in inheritance. Inheritance, we were discussing in classes how you have a diamond effect. You can't inherit from two separate classes. You can implement two separate interfaces. That means that if you have, you're the head of a project, you can now say, hey, this class needs these different pieces. So it's a very powerful tool, and it's one of the ways to force programmers to put in the modules they need and get around the diamond effect. Let's take a look at interface nesting in Java. Nested interface is a procedure declaring a new interface, either an existing interface or inside a class. And let's go back into here, a little play area. Let me just close these out real quick. And let's go ahead and add another package in, and we'll do new package. And we're going to call this, well, instead of interface, let's call it nested interface. There we go, our nested interface package. Finish. And once we're underneath this package, we want to go ahead and add in an interface. And we'll put a new interface in it, and we're going to call this, this is going to be a little confusing, interface outer. And then in our interface outer, we're going to go ahead and create an interface inner. Let me put that in this. So here's our interface outer, here's our interface inner, and our void inner method. And then let's go ahead and add in a class, new class, and we'll call this the nested, oops, and we'll call this the nested IF for interface. And let's go ahead and finish that. So here's our class. And in our class, we're going to go ahead and import inner interface.interface outer.interface enter. Whoops, forgot I changed the name to nested interface for the package. So we're going to import from our package nested interface, interface outer, interface inner. And that just means that we're going from here's our interface outer, and here's our interface inner. You can create a stack of interfaces so that when you send the package out, instead of sending out 50 different interfaces, you can send one interface out with all the sub-interfaces embedded in it. And you can see it highlighted there. The nested if still comes up with an error because we haven't done our override. And we'll go ahead and put in a public here. And we'll just do initiate our nested IF class. I guess nested if. There we go. So let's go ahead and initiate that. We're going to have our object equals a new nested if. And again, if we compile it, and we'll go ahead and run it, and I'll do the compilation here, you can see that it compiles fine. It's not going to give you any errors. But when you hover over here, it says, hey, you need to add unimplemented methods. And you left some stuff out of here that you were told you're going to include, which was this interface inner. And of course, we can simply do that. There we go, make it look a little nice. Do our override. And then once we have our override, we need to go ahead and create the method. So it's telling us we have to have that method in there, or we're going to get an error. And that was our inner method that we included. And then it's whatever we decide to do in here. Let's say we wanted to go ahead and we want to find the first 15 prime numbers. And our team in the back put together a little piece of code for that. It's always fun to throw something in interesting, so you're not just looking at a print. I did something really cool here. That can get boring after a while. So we'll go ahead and do integer. We're going to iterate equals 0, number equals 0, x equals 1, y equals 1. And then while number is less than 15, y equals 1, and we iteration equals 0. So forth. You can see here we're doing what is, if you divide, is there any leftover? If there is no leftover, then that means it's divisible. That's not a prime. Otherwise, if the iteration equals 2, system out is going to print the number, and then we're going to add another number to it and just keep looping through. So you can see right here, this is just a simple set of code, but there goes my error. My error is gone. That's what's important. We have our inner method. There's no more error on here because we've now included it. That came from our nested setup on here. And of course, if we're going to put a code in there to count the prime numbers, we should probably go ahead and do our object method and run that. There we go. And sure enough, we have our 2, 3, 5, 7, 11. There's our list of prime numbers. So just to kind of hammer it home, what is the difference between interface versus class? Interface, keyword used is interface. Keyword used for class is class. Interface does not include instructors, where class has its constructors in there. Interface stores only methods, only the method signature, where class has the storage of the actual definition. So just the signature versus a full method in there. There's no access specifiers in the interface, where of course there is access specifiers are needed in class. No data members, includes data members in class. No static members, includes static members in class. So think of the interface as being just instructions. They're instructions on methods. That's all they are. They say, hey, you have to do this as a programmer because your head of your department said this is what needs to be in here. Or maybe you have a very complicated code with a lot of the same pieces, and it says, hey, don't forget these pieces because we're going to give you an error if you don't. What are the advantages of interface? Well, using interfaces has increased the simplicity in programming. Some of the advantages are complete abstraction is achieved with no ambiguity. And that is very key. That is a whole thing. It's saying, hey, we need these in this class. You have loose coupling between the data and methods. So now your team can have what they need without having to go through and understand what the whole picture is. They can build on small pieces and really focus on it. It resolves the diamond problem. Remember from classes, you can only inherit from one class. Now I can come in and say, hey, these procedures, these methods all need to be in here, and I can have as many methods as I want in there. It resolves the complexities in defining dependencies. So again, you have this whole archive, and it's almost like telling a story. This is what we're building. This is what it looks like. Disadvantages of interface. Using interfaces has some disadvantages. Obviously, the first one I look at is if you're working on a really small project, you've added a whole layer of complexity to it. So when you're working on smaller projects, you almost never see interfaces. The interface in the real world project is used either extensively or not at all. And so you'll see instead of an interface, they'll just send you a list of what you have to have in there. That's pretty common, but with the interface, it forces the programmer, so when it goes back up the chain and everything needs to be put together. And so it gets a little confusing because some people are like, oh, I got to use an interface or I don't. And the use of the interface can reduce the execution speed. You're adding a whole nother layer there where it has to look that information up. And so if you're doing like a huge multi-task process and you're spreading it across multiple processors, and so now you have hundreds of these classes that are pulling in hundreds of these interfaces, that's going to add a little ding to your speed, and it might not be something you want to do there for a process like that, which is very different where if you're writing a game and each player and each module for their character, which has certain things they have to do, which is move left, move right, move up, down, and then they have all the new games always have a special thing they can do that has to be embedded into that class.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is, it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are, first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next, and I'm gonna name it as encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class, and I'm gonna name it as employee. So in this program, we are going to use a classic example of employee using employee name, ID and salary. So in this class, let me create variables. First string name, then integer ID, and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that, I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.setID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First, I'm gonna set everything. And lastly, e.setSalary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this, I'm gonna go to a print statement and then name and not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case, that's Simplilearn. And next will be ID and e.getID. And lastly, salary, e.getSalary. So this is a simple program that is used to define encapsulation we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables, so that it's secure and no one can access the variables directly. So now let's run the program. And there we go, we have our result. We have executed the program successfully, and as you can see, name Simplilearn, ID is 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse. So with this, let's move on to our next program to understand it better and how we can manipulate these variables or methods using program. So again, let's create a new project. And this time I'm gonna name it as encapsulation 2 because it's the second program for encapsulation. And here we have our main program. Now this time I'm gonna use an example of cars. So let me just create a new class and I'm gonna name it as cars. So in this, again I'm gonna create 3 variables that are private. So first I'm gonna get string name, then private string price, that means price of the car, and third one top speed of the car. So we can create the program that we did before as it is, but I'm gonna explain you more in depth how we can manipulate these variables or classes. So I'm gonna create a constructor for the class cars, and inside I'm gonna give it as arguments as string name, then string price and string top speed. And I'm gonna give it as this dot name is equal to name. This is so that the class can identify that we are going to give arguments related to that, and the class can return the values of it. So similarly, I'm gonna give it as this dot price is equal to price, and lastly this top speed is equal to top speed. So with this we have completed our constructor for it. Now let's have getters and setters for the same thing for these 3 variables. So generate getter and setter, select all, and OK. This is a great feature that we have in Java, getters and setters. Otherwise we'll have to type the whole code. So with this, let's move on to our main program. We'll write the code here. First I'll create object of the class cars, and inside this I'm gonna give arguments, or inside this I'm gonna give values that I use in constructor to assign the values without using any c.getName or c.getPrice. So my first was name, so let me just name it as BMW. The second thing was price, so I'm gonna give it as $30,000. And the third one was top speed. So top speed, I'm gonna give it as 200 km/h. So we have assigned all the values to the variables, and we have created object as well, all in the same line. So this is another way of creating objects, or another way of assigning values to the variables that are private. So if I try to print these, they can be easily printed. So in the starting, name and c dot, so this time I'm gonna give get name, so it automatically gets the value that I assigned to the variables through getters and setters. After that, price c dot price get price, and in the end top speed c dot get top speed. So if I print this, let's execute it, and there we go, we have name BMW, price, and even the top speed. Now if I give spaces between them, it will look neatly. So let me execute it once more. And here you go. Name BMW, price $30,000 and top speed 200 km/h. So this is one of our ways how we can declare variables or assign values to the variables without using any getters or setters. So in this method we used only getters to print the value that we have for variables. Now how can we manipulate the variables if we want to change value of them? Now for this again I can do set top speed or set price. Let the name be as it is. So c.setPrice. So price I'm gonna set it as $50,000 and c.setTopSpeed. Let me increase it to 250 km/h. So before printing that, so that we can differentiate which one is new and which one is old, I'm gonna print one more line, stats after updation. So now if I print these values, I'm just gonna copy paste it. So now if I print it, let's execute it. And here you go. First we have name, price and top speed, then stats after updations. That means after we set the value gets overwritten on the variables, and now we have a new price and top speed and all the details. So this is how you can manipulate variables or values inside the variables. Now let's see what is inheritance. When one class inherits some properties and attributes of other class, it is known as inheritance. Let's have a look at an example. In this example, mobiles is a superclass that have variables like cost, color and RAM. The classes that inherits the variables and methods of mobiles are Samsung, Xiaomi and Nokia. These classes are known as subclass. Now let's see the types of inheritance in Java. First, we have single inheritance. In single inheritance, one class inherits features from another class. As you can see above, class B inherits all properties of class A. This is a simple concept of inheritance. Next, we have multi-level inheritance. A derived class inherits from base class, and derived class also act as a base class to other class. Sounds complicated, right? Now let's see this example. Class B is derived from class A. Then class C is derived from class B. Because of this, class C contains properties of both class A and B. This is very effective when you go for inheritance in big programs. And lastly, we have hierarchical inheritance. In this, one class serves as base class and two or more classes serves as derived class. As you can see above, class B, class D and class C have a single base class A. So three classes inherits properties of single class. This is called hierarchical inheritance. Now, to understand these all concepts better, let's use Java code. So now let's create a new project. Next, and I'm gonna name it as inheritance. So we have our main program here. So I'll just create a new class, new Java class, and for now let me just name it as mobiles. So what are the features in mobiles to start with? The cost of the mobile, the color of the mobile, and what can we do it as, or RAM of the mobile. I am making it as string because I'm gonna write GB as well, so that's why string. And now let's use getters and setters for this. Select all and OK. So we have our first class mobiles here. So our first type of inheritance was single inheritance. So I'll create one more class and I'm gonna name it as Android. And I'll make Android as extends. Okay, I'll leave it for now. So this mobile class we are going to use afterwards. For now, I'll use only Android. So let me make it as string Android version. And for this, I'm gonna go for getter and setter. So what is single level inheritance? One class inherits from another class. So I'll create one more program, or I'll create one more class and I'm gonna name it as Samsung. because Samsung is an Android phone and as well as it comes under mobiles. So now I'm gonna extend it to Android. Extends Android. So no need of writing anything inside it. As soon as I write extends Android, I can use all the variables. Right now I have only Android version as the variable. So now let's go to main program. And I'm write Samsung S is equal to new Samsung. So I just created an object of it. So now if I use S dot, I'll get Android version. So I'll set Android version as Android Pie. And now to show it, I'm gonna give it as Samsung Android version. And here S dot get Android version. So now I have Android class and a Samsung class, and I extended Android class to the Samsung. So Samsung can use all the variables here, and I can even set the variables here. So if I execute it, and here you go, you can see Samsung Android version, that's Android Pie. So without even declaring even a single variable or method here in Samsung, I used the variable of Android and I did this. So this is called as single level inheritance. So next I'm gonna move it for multi-level inheritance. So what is multi-level? One class is derived from next and this class is derived from here. So I have three classes right now. So I'm gonna put Android extends mobile. So now Android can use all the variables of mobiles. I can use cost, color or RAM, and even Samsung that extends Android can use all the variables from mobile. So if I put variables for it, S dot, see I can get color, cost or RAM. So I'm gonna go for set color. I'm gonna give it as black. And next S dot set cost. Cost I'm gonna give it as 30,000. Let it be dollar or rupees. And the last one S dot RAM, I'm gonna give it as 4 GB. So now if I print, I'll just delete all this. So now I can print them one by one. So let's just do that. So I'm gonna give it as Samsung mobile details and then cost S dot get cost. Next I'm gonna give it as color plus S dot color, S dot get color. And next last one I'm gonna give it as RAM plus S dot get RAM. So now you can see I have not declared any variable inside Samsung, but I inherited all the variables from here, mobiles and Android. So all the variables from mobiles are here, and as per Android, if I put Android version S dot get Android version. So now if I execute it, I'll get all the values, and as a result I'll get everything that I gave as the value. So now let's just execute it. So instead of cost I should put color. So as you can see, I have the cost of Samsung mobile, color and RAM and even Android version. So all these variables I gave in mobile, and Android version I gave in Android class, but nothing in Samsung class. So this is how multi-level inheritance works. So now let's move on to the third topic, that was hierarchical inheritance. So what is hierarchical inheritance? In that, three classes or two classes have a single base class. So I'm gonna create two more classes that derives Android. So now let's create them. Next I'm gonna name it as Nokia, and the last one Xiaomi. So these are real-time examples, three mobiles, we have three different companies and all uses Android and they all come under mobiles. So now in everything I'm gonna write extends Android. So this is the final version of inheritance that we have, and this is very simple to understand, but it might get complicated when we use big programs or very large programs for some project. So now I have nothing inside class Nokia or Xiaomi or Samsung. I'm going to use all the variables that come from Android and mobiles, as Android extends mobiles. So this is the concept, like I have three classes, three mobile companies that comes under Android, and we can use them to manipulate the variables and assign values to the variables. So I already have everything from Samsung. So first let's create objects for all these classes. Nokia N is equal to new Nokia, and Xiaomi X is equal to new Xiaomi. So now I'm gonna assign variables to their values. So now let's start with Nokia. N dot set color, let's give it as red. N dot set cost, I'm gonna give it as 40,000. Again, doesn't matter because it's a normal program, so it doesn't matter whether it's dollar or rupees. So next, N dot set RAM, RAM 4 GB, and lastly N dot set Android version, Android Marshmallow. So, and in the end I'm gonna give X dot, let's just copy paste it, so it will be a lot easier for me to code or for you to code. So here X dot, and color I'm gonna give it as silver, rate 50,000, RAM 6 GB, and Android, let's give it some old, so KitKat. So now we have set all the values to the variables. So now let's print them as well. So again I'm gonna copy paste all those details. Instead of Samsung, Nokia, here it gets N instead of S, and now again copy paste. Now Xiaomi, X dot X, and finally X. So with this I have completed the program. I can show you all the values that I gave in the starting. Let's just revise it. So in mobiles I gave all the variables, cost, color and RAM. Android I extended from mobiles and I gave one more variable as Android version. Nokia, Xiaomi and Samsung I gave nothing, but I only extended Android. So now let's execute it. So we have successfully executed our program. Let's have a look at it. So here Samsung mobile details in the starting, color, cost. After that Nokia mobiles, and in the end Xiaomi mobile, and everything that we gave as the value are here. So with this we have completed our program. I hope you understood what inheritance is. So I'll just revise it one more time. So in single level inheritance I used only Samsung, Android and mobiles. And Samsung I derived from Android and I used only Android version in the starting. Next I used multi-level inheritance. In that I used mobiles, Android and Samsung. With the use of mobile variables I used Samsung and I printed the values of color, cost, RAM and Android version as Samsung. In the next, that is hierarchical inheritance, I used Nokia, Xiaomi and Samsung.
What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom, it can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor, and we're going to do some animal sounds with cows, cats, and dogs, just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package, and we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here. And we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So, yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just, good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here, animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in a, let's start with a cow. Yeah, why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class, but a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog, why not? So here comes in our dog. And of course we want the dog to actually say something. And we'll have the dog go bow wow. And then we'll go back to our animal main and we have to create a dog. And we'll say cow. Simply dog, dog. Uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound. So we'll go down here and go dog.sound. And when we run this, as you expect, it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and I went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, in Java, the process of method overloading is achieved when a class has two or more methods with same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string, and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if-then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this one's going to print out the dog says growl growl. Now if we go back to our animal main, and here's our dog, same sound, but now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl growl. So the dog says bow wow, and then the angry dog says growl growl. So there is another thing called operator overloading. Operator overloading is not supported in Java. The authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here the overriding method gets resolved in execution. So far we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is a predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, this is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super dot sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains, and it's printing out or doing whatever it does here. At this point, we usually have it return something, so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs to handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as the method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see where as you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then it actually is very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. Just depends. The more you use it, the easier it is.
What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic, where we face the Java collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java collections API. To understand these in a much better way, we shall now go through the Java collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65. And the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in three names, which are David, John, and Stacy, into our list. And also we have a fourth addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the fourth element, which is the duplicate of the third, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the fourth element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or poll. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits: apple, mango, grapes and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the dequeue interface. So what exactly is a dequeue interface? So a linear collection that supports element insertion and removal at both the ends is called as a dequeue interface. The name dequeue is short for double-ended queue and is usually pronounced as dec. Most dequeue implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted dequeues as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the dequeue. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for dequeue interface. So here we are going to add in some elements into our dequeue and then also try to remove the first element and print the updated dequeue. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the dequeue were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that the updated dequeue is having 2 elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains 3 general purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add 3 elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names are being arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron, and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly, and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this, we finished the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3, and 4 in the matrix form, and we are going to use two for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3, and 4, and the elements are printed in the matrix form. at the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked list also come under Java collection classes. There are three types of linked list, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into two parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation, which stores the second element. Similarly, the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3, and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3, and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have two address locations. So the first address location of the head stores null, and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have two addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4, and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3, and 4, and 5. So this is how the doubly linked list work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6, and 7, and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for hash map class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this, we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in this order. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally increased speed in programming. So these were the major benefits of Java collections. What is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, These types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arises is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic, where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors, for example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by a few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. or in other words, it might be system defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see on our screen, we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string abc has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen, we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this, we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value, which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as, if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow, if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources.
What is JDBC? JDBC is a tool or an application programming interface that establishes a connection between standard database and Java application that intends to use that database. Need for JDBC? Establishing database connectivity to execute MySQL or SQL queries and DDL/DML commands. View and modify data records. And one of the most important things to look at when we're talking about a JDBC, and probably the most confusing part where the devil's in the details, is data types in a JDBC. So when we start looking at the data types and you're setting up your data, you have your SQL, which is your var character, and your Java equivalent, java.language.string. And you have your bit in SQL. In Java, it's Boolean. In SQL, it's numeric, java.math.bigdecimal. Integer, int, real, float, float, float. So there's no real difference in Java between a real number and a float number. Your double is double. Your binary is a byte. Data, Java SQL date. So your date in java.sql date. And there's also your SQL timestamp, java.sql timestamp. Array, java.sql array. Reference, java.sql.reference. Structure, java.sql structure. Character, java.language.string. Big integer, long in Java. Variable binary is a byte. A clob, and that's character large object. And then the equivalent is java.sql.clob. And then you have your blob in SQL, which is a collection of binary data stored as a single entity, and the equivalent in Java is going to be your java SQL.blob. Now, if you're doing a lot of programming, I would suggest having a cheat sheet there, and then once you're up and running, you'll start to remember most of these just because out of use. With the JDBC architecture, we're looking at the application, then it goes into the JDBC API. So you have your application you're writing, your Java Database Connector API, then that has a manager underneath of it, and then you have your Java Database Connection drivers. And the drivers are the ones that are transferring that, whether it's an SQL server, MySQL server, the Oracle database, or different sources that use a JDBC connection. JDBC environment setup. So when we talk about the environment setup, we have Java and your environmental setup underneath of that. In setting up a Java environment, you have to download the latest JDK, set Java to home, and set your Java path. So if you're just using Eclipse for the first time or whatever IDE you're using to program, you want to make sure you have that all set up and you have the current JDK in there, the Java development package. And then with MySQL, setting up MySQL environment, download the latest MySQL workbench, extract the file, run the setup file. And that'll get you set up with your own MySQL on your computer. And MySQL registers with your operating system. So it's kind of like a global variable when you start accessing it. And it's designed that way because normally when you're using an SQL or MySQL database, it's installed on a server. So it makes sense that you want it registered with the operating system so it's accessed globally. Steps to connect your JDBC. Step 1, import your packages. This procedure is followed to make sure that the relevant packages are readily available for the API. Step 2, load and register your driver. The imported drivers needed to be loaded and registered for establishing a connection between application and database. And if you remember, in this case, we're doing the MySQL, so we make sure our MySQL driver is installed. And step 3, connecting database. After the first 2 steps, the next stage is to connect the database. This can be done by a GET connection. Step 4, writing a query. So now we're actually starting to get into your scripting. Here we write in the SQL command or query that we need to execute. If you're not familiar with SQL, it's good to have an SQL cheat sheet set up. Once you start understanding how it's put together, you'll find that it goes really quick and it's pretty fast to learn, but it is its own query language, and you do need to learn a number of the main settings and poll language so you know what you're doing. Step 5, executing query. Now the query from the API is executed using execute query, and we'll actually load that up just as a string variable. When we look at that, you'll see how that fits together. Step 6, processing result. After step 5, the system basically does 2 things. It processes an output and retrieves the values from your query. And then step 7, closing statement. The result set and statement needs to be closed explicitly. And you'll find there's 2 closing statements. There is your result set, which is still pulling from the database. And then step 8, which is we need to actually close, closing connection. So the last stage is to disconnect ourselves or the API from the database. So we no longer have that open connection using resources. So we're going to jump into our Java database connection example. And we're going to do that with what we call the university database. Let's start with a basic overview of MySQL. And you can go to dev.mysql.com. And you'll see here we can look up more information. They have the download of the newest version. This is a full SQL database package. And some of these you can actually go in there, and if you're doing database management, they can spread across up to, usually don't want to go more than 5 servers, but it is designed to go up to 5 servers kind of set up with terabytes of data in there. For a developer on the programming side, we usually want to install something like MySQL locally. So on my setup, it has no network connections. It doesn't auto start on the boot up of the computer, and I have it locked down. That way, if I use some kind of simple password or something like that for one of my demos, it doesn't go anywhere. No one can access it. Now, another option to MySQL is also the SQLite. And you can go to the sqlite.org, read more about it, and download it. It has a couple limitations that you're not going to see in your full-scale MySQL or Oracle or SQL, but most of it will transfer over. And so for a small project, you can actually use it as the backend for storing your data. You can also integrate it or upgrade it into MySQL because most of the SQL commands are the same. And when you go into the MySQL, which is a significant download versus SQLite, you can certainly go down to downloads, and then there's also the connectors. So devmysql.com/download/connector/j. And I bring this up because it depends on how you've set up Eclipse for your interface and your IDE, and it depends on what you need and how exactly on your setup as far as the connectors. We'll look at that a little bit more closer. In the MySQL, it isn't Oracle based, so you'll have to set up an account if you don't have one. You have to log in. It's all free. As long as you're not doing like the enterprise with all the support and help on it, you don't have to pay for it. It's an open source. Now, once you've installed MySQL, and if you do SQLite, you're not going to have these interfaces. It'll all be done from Java code. But once you've installed MySQL, it's going to add in a terminal window and then also the workbench, which is just a nice GUI interface for MySQL Server. And we're not going to do anything with the workbench. You can play with it certainly, because a lot of times you don't have the workbench installed on your computer, especially if the MySQL is set up on a different server and you're remote accessing it. Especially if you're in the classroom or something like that, they probably have sent you your login information so you can get into the shell. Quick note though is if you do your own MySQL, just note that I kept this as a local host. You can actually see it down here, root localhost, no outward connections. And that's just to protect my computer. Once you start opening those, you have to be aware of your passwords. And since I'm doing demos, I want to keep my passwords really simple, so that's not the focus of the programming. I had to log out and relog back in. So once you've gone in there, you should have this. A lot of times your interface might be web-based if it's a remote MySQL connection you're working with, and it'll prompt you for your username and password. In this case, mine is on my computer. It automatically has me log in as admin, so I have full admin rights. And then we always like to start by, at least I do, is show databases. And these are the current databases on here. They have some different information on them that is part of the basic setup, and some examples like Sakilla and World are both example databases that automatically load with MySQL. For this example, we're going to create a database, and it's going to be university. We'll do capital there, university. Don't forget our semicolon, and time. You can see how long it took, 0.69 seconds. And of course, if we go show databases, you'll see now that there is a university in there. And we want to go ahead and use university. That means that whatever we do, any commands that we have in here for tables or whatever are now going to be going into the university database. So now our database is changed. And let's go ahead and zoom in. Let's see, here we go. Set. Okay. A little bit more so we get the nice big print so you can see what I'm doing a little bit better. There we go. All right, so we're going to go ahead and create our table. And this has all been prepared, so I don't have to go through and redo it all the time. You'll see here we're going to do create a table engineering student. And then we have student ID as an integer, not null. Department variable character 25 long, first name, last name, pass out year, university rank, primary key. In creating this, note a couple things. First, we created a table, engineering students, and we've gone ahead and created the fields as part of the create setup here. And the things I want you to note is that we have our integer. So our student ID is an integer, our department is a variable character, and it's 25 long. And the reason I say that that is really important is when we flip back on over here, if you remember from our, there we go. If you remember from our data types, here's our variable character. And in Java language, that's a string. a string doesn't say, hey, it's only 25 long. And so you got to be a little careful when you're pushing and pulling this data, especially when you're writing the data from Java into the SQL, that you check for that length of that string. And then the integer is, of course, an integer. And, of course, your other data types, you can see how they follow suit. But with variable character, be very aware of that is a designated 25 characters long. And we're going to go ahead and insert some data in here. Here we go. We'll go ahead and insert into engineering students values. And this is going to be the student ID. And it's also the primary key. So keep in mind that that is a unique value in there. And then we have CSE, Computer Science Engineering, Karan, Akaria, 2018, 1272. So there's our pass out year, 2018, and ranked, I guess, number 1272. I'm not sure where the, oh, that's a university ranking. There we go. And then we have some prepared data, which I just went ahead and pasted in. So we have a whole bunch of individuals in our database now. And it's the same line over and over again. Insert into engineering students, values, and then you have your list of values. And we can see that by doing a simple select. We'll do, star. So it's going to select everything, one of our hot characters. If you're not familiar with SQL, get a setup on there and look it over. And you can also download a cheat sheet from somewhere with all the different commands in there. I myself do a lot of consulting, and so I'm always jumping around from one platform to another. If you're doing that kind of work, it's more important to understand the limitations and the advantages of different systems, and then you have your cheat sheets for putting together stuff really quickly when you need it. And you can see here the data we just put in there. There's our student IDs, department, first name, last name, pass out year, and university rank. And we'll go ahead and do one query in here real quick. We already did one query. We're going to do two queries. We did select star from engineering, and then we're going to go ahead and select student ID, department, first name, last name. So you can actually choose what you select instead of doing the asterisks. Where student ID equals 10202. And when we go ahead and execute that in here, oops, there we go. You'll see that it returns the one individual with that student ID here. So let's take this back into our Eclipse because we're still doing the setup. So you have your MySQL Server setup, or you did SQLite with a little bit different setup going on there. And let's flip on over and see what's going on with Eclipse. So in Eclipse, we're going to go in new. We'll start a new project. And we'll call this JDBC. It's our JDBC project. Whoops. Select a wizard. I forgot where I was going on there. It's a Java wizard. We're looking for this project. Java project. There we go. And we're going to call this, there. Now we're in the right spot. JDBC package. That way everything will be bundled in there in the same package, and finish it. Create. All right. So you can see right here we have our new JDBC package we're working with. Now at this point there's a lot going on as far as your options. If you set this up for doing database management, which I did not, and I'm going to show you the two different ways, you can go under Windows and under Preferences, and in this list you'll see database management, and then you can just go in there and set it up this way, and it'll pull in that information for your SQL connections. Now, if you did not, and you downloaded the MySQL, it does have an option to download the Java Connects, which would put it into wherever you installed that at, which is default under your C drive program files. Now, on mine, I didn't. I downloaded the connection separately. And there's two different ways. We can go under Project, and under the Build Project, give that a moment to come up. Oops. Properties. There we go. The Project Properties and the Java Build path. This same window can be accessed by right-clicking on your package we're working on, and then we can go down to Properties, and you'll see the same window opens up. And we're going to go under Java Build path, We're going under libraries. So these are libraries we want to include in our setup. And then I click on our module path. And at this point, you'll see add external jars here. Now again, if you have it already pre-set up in Eclipse, you can just add jars and it will be in the jar library. So there's different possibilities there. But I did a download, so I'm going to go add external jars. And I happen to keep mine on my D volume under my SQL. And you'll see my SQL connector Java, and this is MySQL 8.0. And I just go in here, oops, there we go. I just go ahead and open this up, and you'll see right here it has my connector Java. Once I set that in, it's now added those packages, and there's hundreds of actual subfiles in there, and it's all set to go. And I can apply and close this window. And now I'm ready to go ahead and start writing my script and start building a program in here. And let's go ahead and go under source, new, and we'll go ahead and put in a new class in here, and we'll just go call it JDBC. Same as the package. We'll go ahead and finish that. And we're set up with a new class in here. And once we've got this set, the first thing we want to do is we want to go ahead and import all of our Java setup in here. So we have the Java connection, and now we want to go ahead and import it. And when we look at this, we can see we have our connection. And remember, two of these have to be closed explicitly. And that's your connection and when you create the statement. You have your driver manager. So when it goes in there, that's the piece that connects to, actually does the connection to the database, the drivers that convert everything in the code in there. So you have your connection to the database. You have the code that converts it. You have your result. So you're going to get a result off of your query. Then you have your exception. So if you have an error throws or something like that, that's where that's going. And of course, the actual statement that you're going to send to the SQL server. And of course, we want our Java to be able to actually run. So we'll put our main in there, public static void main. And it's going to throw the SQL exception. So you'll see right here, that's what we're working with, and there's our Java SQL exception on there. So the first thing we're going to need on our setup, let's put that in here, is going to be our connection information. We need to know the username, and we're just going to call it string uname equals, in this case, I created a user, Richard_Simplilearn, and then I created a password, my password. Remember, this is a local host. So you probably don't want to have a simple password like that, but this whole database is locked down on just this computer. There's no outside network access or anything like that to get in here. And then, of course, this is a separate user, so it's not even my admin or root user. And then we go ahead and put a query right here. In this case, we'll start with our most basic query. If you remember, we already did that on our, at the very beginning, select star from engineering students. And we're going to use that query in our code to start off with. And then another really common thing when you're setting this up is that we also want to test it and see, hey, did we import our package correctly? Is it set up correctly? So remember, we came in and we imported our MySQL connector jar file. In the code, we would just want to make sure it's working correctly, and that's what this is. It says try class for name, and then it has our com.mysql.cj.jdbc driver. It's saying, hey, do we have the driver for this? That's all that's doing. And if not, then it's going to print an error so we can find out why it doesn't have that driver. And then next, we want to actually start getting into our actual code. And in here, we're going to do a try, because whenever you do any kind of major connection, you want to make sure that you're looking for your errors. You're not going to mess on anything. And we're going to do a catch. And so we're looking for any kind of SQL exception error. And for this demo, we'll just do, print it out. So, oops, wrong spot. It goes into the catch section. There we go. So we'll print it out over down here as far as the error on there. And it's an SQL exception, so it's still looking for the code, which we haven't put in here yet. And this is really where the magic really starts to happen, because we have our connection. And there we go. And you'll see that the connection is, that's all this is right here. Here's our connection up here. And we pop it down here. We have a connection. We'll just call it con. Do one end, so keep it uniform. There we go. And this is going to go to the driver. So in other words, right here, we're going to go ahead and need the driver manager, and that's where we imported here. And it says get connection because that's part of the driver manager. And we have our URL. Let's see, and we of course forgot to put the URL in up above. So let's go ahead and go back there and put that in. And the URL comes out as a JDBC MySQL. That is registered with my computer. So my computer has, when it's running the MySQL, this is the local host. In this case, we call it university. That's where this comes from. And that's all part of your MySQL setup. If you're working with a remote database, you'd want to get this information from the remote, whoever set the database up, so that you have this particular line of where to call. And so when we go back down here, we have our connection. It's all set up on here. The next thing we want to do is we want to go ahead and create our statement. And this initializes it. So we have a statement called statement. But this statement's going to be based on our driver manager, which is then connected to the connection. So these are all connected to each other. And this generates the format it needs for when we actually send our inquiry. Remember, here's our query right here. So we're going to send select star from engineering students for right now. We haven't put that part in. We're just creating the class or initiating the instance so that we can do that. And then once we've initiated the instance here, oops, go down here, we need to go ahead and generate a result. And so we have our result set. Again, that comes up here from what we brought in. We're storing the data coming in, or storing the pipeline to bring it in. We're just going to call that result. And then we have, this is generated from our statement. Here's our statement. So this is all like linked together. Here's our execute query, which is part of the statement. And here's the actual query, which is coming that we put together, the select star from engineering students. And then finally, we want to actually do something with our information. So what we'll do is we'll just loop through it while. And here's our result set that we just generated. So while result dot next. And this just generates a Boolean. So it says, hey, there's still another result coming in. So we need to go ahead and get that next result. And we'll go ahead and create a... and we'll take that string university data, and then we're going to loop through the different results. There we go. Integer, and then here we go, university data. And we want to tag on the end of it result.getString_I. So what's going on here? We just did a bunch of things. We are going through each row, result.next, each row of data that comes off of the database until this returns null. There's no next result coming in there. And then we come in there, we look at the result. The one we're looking at is the current one, so it goes through, I forget how many we put in there, about 20. It goes, row 20 with 0, row 1, row 2, row 3, row 4. And then on each of these rows, we have a string, and it's an array of strings. And we're going to get that string, and it returns I. So this is get string of column I. So we have row and column. And really important in today's programming to really understand rows and columns, because it's so central to most of the data processing going on. And then finally, we want to go ahead and see our results. So let's print them out. We'll put in our nice print statement, system out println university data. So this is going to print each row as it goes through it. And then I'll reset the row again to an empty string, and then I'll add each of the columns to that row from our result, and then we'll print the next row out. And now that we have a complete code, let's go ahead and go up here, hit the run button. It's going to compile it, runs it out, and we can see down here, let me just get my double mouse so we can get a better view. Here's our different, your ID comes up. I forget what the actual setup was, but the CSE, the name, the date, the ranking, all that prints out one row at a time, and that's what we're doing here. Of course, if you're processing the data differently, you might be loading this into a user interface. This might be generating other information. You might be doing statistics with it. But you can see how it's set up in here as far as pulling the data into the Java format and then running it from there. Just so we can get a quick glimpse of where this goes, let's go back up here. And we're going to flip back and forth between a couple different screens. So let me do that. And here, if you remember, we did select star from engineering students. And there's the same thing up here that we got down here. This is our MySQL Server interface, and this is the interface we built in Java. And if you remember, we also did this particular selection: select student ID, department, first name, last name, pass out year, university rank from engineering students where student ID is. And we got the single row on here. And this is kind of interesting because I switched something in the code here where this could cause a problem. It won't on this one. Let me go ahead and paste this in here, and we'll run and compile this one. And you see it comes out with the single user. So the danger of this particular code is that I went ahead and hard-coded in a loop for I equals 1 to 6. And so this one we pulled, it just happened to be that we selected 6 different columns in here. So you got to be a little careful when you're coding in here. What are you pulling and where is it going? You can see if I take out, let's do, we'll just remove the student ID. And we're going to run that without the student ID. Recompile it, there we go. And it gives us a bunch of errors because it doesn't see we're short a column down here. So when it gets down to this code down here, under the while statement, and it goes, hey, where's number 6? Well, there's no number 6, and so we get a lot of errors on that. And you can see where our queries, let me just go back up here and paste another query in. There we go. And we'll run this one, and what we're looking at is we're going to go ahead and do the same columns, and we'll just leave this as a star to make it easy. So we're going to select all columns. From engineering students where the pass out year is 2018. Just do a copy of that one. And we'll run that. It recompiles. And you can see here's all the 2018 on here if you look at the dates. So they're all 2018. And that's the same as our query directly into the SQL Server. If I do the same thing on here, you'll see they're exactly the same. And just because we're having fun, let's flip this back over here and we'll do one more SQL Server. And let's do in this one, let's see, let's just take this whole thing out here. And in this one, we're going to pull in all the departments, but I want the minimal university ranking as the highest from engineering students. That way we can get an order of the rankings on here. And we'll go ahead and run this. And there we go. There's our minimal one. So this one hit the lowest ranking on there, or closest to number 1. And we can do that in here and get the same result. There's Karen. Karen is awesome. Ranking number 96. And you see all these other people that are ranked way below Karen. So this guy must be super smart. So that concludes our JDBC example, University Database, where we took a quick look at MySQL Server, or you can do SQLite, and some basic queries you can put in there and how that works.
We will discuss all the most frequently asked questions in the interviews based on the pattern programs in Java. First of all, we will discuss the right angle triangle pattern. So basically, the right angle triangle star pattern looks something like this as it is shown on my screen. So to resolve this problem statement and print the pattern, we must assume that this particular star arrangement is made in the form of a matrix, where the first row has single star, and the second row has 2 stars, third row has 3 stars, and so on. Now to execute this particular code, we might need 2 for loops. So the first for loop will be for printing the rows, and the second one will be for printing the columns. Now let us execute a practical program and see how does it work. Don't worry about the codes that we will be executing here, because I have formatted a draft about all the codes that I will be executing today, and that particular file will be attached in the description box below. So I think my screen is visible to all. On my screen, you can see the particular pattern, which is a right angle triangle star pattern. So as discussed before, we will have the first outer for loop, which will be for printing the rows. So inside the outer for loop, we have the second for loop, which we will be using for printing the columns. You can see I have defined the row value as 5, which means we will be printing the star pattern for 5 rows. And we have used a counter variable, which is I, which is assigned the value of 1, and the comparator operator is used here, which is I should be less than or equal to the number of rows declared, and followed by that we have a pre-increment operator, and once the condition is true, the control will be entered into the second for loop, where we have the next counter variable, which is j. So we have assigned j is equals to 1, and the comparator operator, which is j should be less than or equal to I, which is the value here, which is in the outer for loop, and followed by that we have the pre-increment operator. Once the condition is true, the control will enter into the inside for loop and will print a star. So here, just let us assume that the value of I is 1 and the statement is true. So the control will enter into the second for loop and it will see the conditional operator here. So j is less than or equal to I. So value of 1 is less than or equal to 1 and the star will be printed. After that, we have the pre-increment operator. So here the j value will be incremented to 2. Now if we compare the values, 2 is not less than or not equal to 1. So the condition fails here. So it will not print a star again. It will come out of the inner for loop and it will see the next statement, which says it should print in the next line. Whereas in the inside for loop, you can see we just used print, not print in the new line. So it will come to the new line and go back to the for loop again, and the increment of I will be taken place and the same runs again. Now let us try to execute this program and see the output. So you can see that the program got successfully executed and the right angle triangle star pattern is print successfully. Now let us go into the next type of program. So the next type of program is the inverted right angle triangle star pattern. So similarly, according to the previous example, we also consider this one in the form of a matrix. So you can see that in the first row we have 5 stars. In the second row we have 4 stars. Similarly, so on. Now let us try to check out the code and learn how does it work and how to print the star pattern on our screen. We are back in the practical mode again. So the kind of pattern that we wanted to print is this one, which is a little bit similar to the previous one, but only thing it is inverted. So the code is pretty much the same, but the only changes that we need to do are related to the comparator operator. In the previous example, we chose that I should be less than or equal to 1, and in the next stage we used pre-increment operator. In here we are using a different one, which is pre-decrement, and inside the for loop we have the j comparator operator in the same way. So here we have declared the row value as 5, and inside the for loop we will equate the counter variable equals to rows, which is 5, and followed by that the comparator operator compares if the value of 5 is greater than or equal to 1, and followed by that we will use the pre-decrement operator. Once the condition is true, the control will enter into the inside for loop, and here the counter variable j is assigned to the value 1, and the condition is j should be less than or equal to I, and followed by that we have the pre-increment operator, which is ++ j. So once the condition is true, it will print the value of a star, and followed by that it will again continue the loop. So here the for loop will work in the following way. Int I is equals to 5, I is greater than or equal to 1, which is true, and pre-decrement. So the condition is true, so the control will enter into the inside for loop where it will again compare with value of j. J is equals to 1 and j is less than or equal to 5, and followed by that we have the post increment. So the control will enter inside the for loop and print a star, and followed by that in the next instance the value of j will be incremented to 2. So 2 is less than or equal to I, followed by that pre-increment, and in the next iteration it will print a star again. So this will continue until the condition is true. Once the condition fails, the control will exit the for loop and print in the next line. You can see that we have print in the new line here, which is unlike the print function which is inside the for loop. So this will continue until the statements are true. Now let us try to execute this program and see if the desired pattern will be printing or not. There. You can see that the program got successfully executed and the pattern which we desired for is printed on the screen. Now let us move ahead into the next type of pattern. So the next type of pattern is the arrow-shaped pattern, and this almost looks familiar to the previous two programs. The only difference is we have combined them together to form an arrow pattern. Now let us try to combine the previous two programs and print this. So now you can see on my screen we have our desired pattern which looks like an arrow. So as discussed before, we are trying to combine the two programs that we executed before. So the first half of the program is designed for the first half of the pattern, which is completely similar to our first program. So the second half of the pattern is from our second program. But the only difference here is we have considered the value of rows is row minus 1 because we don't want another extra row to be printing here in this way. So you can see if we used I value is equals to rows, then the pattern would be something like this. We will not have a pointed edge. So to get a pointed edge, we will use row minus 1 to get this pattern what we desired for. Now let us try to execute this program and print the output. Now let us enter the number of rows we want. Let's enter 5. So there you go. Let me expand my output screen. Yeah, there you go. We have the pattern which we desired for. And don't forget that we need to use row minus 1 in the next stage, which is the second half of the program. So this is how the arrow pattern is printed. Now let us move further and see the next type of pattern in our list. So in the next pattern, we have the right angle triangle, which is completely similar to the first one, but the hypotenuse is on the other side. As you can see, this is the difference between the first program and this program. So in the first program, we had the hypotenuse in this direction, and now we have the hypotenuse in the opposite direction. Now, similarly to the first program, we shall consider this one as well in the form of a matrix. So you can see, if we consider this pattern in the form of a matrix, we have 4 spaces followed by a star. Similarly, in the second row, we have 3 spaces followed by 2 stars. In the third one, we have 2 spaces and 3 stars, and so on. So the main point that we need to consider here is, first we need to print the spaces. Followed by that, we need to print the stars to get this pattern. Now let us execute a practical program and see the output. So back in the practical mode, you can see on my screen the desired pattern what we are looking for is this. So here the only difference is we have to print the spaces first. So for printing the spaces, we will be using this for loop with the condition j is equals to 2 into n minus I, and j should be greater than or equals to 0, and j decrement, which is a post decrement operator. So what is the value of n? N is nothing but the value of rows. So the value of n is declared in the main function, and n is equals to 5. After that, we will be calling the print stars function, which is over here, and the value of n will be carried over here, and then the counter variables I and j will take care of the for loops. Now let us try to execute this program and see the output. So you can see that the program is successfully executed and the desired pattern is printed successfully. So this for loop will be run until the condition is true. Once this for loop fails, we will enter into the next for loop, which is particularly designed to print the stars. Now after this, let us move ahead into our next type of pattern. So the next type of pattern is an inverted right angle triangle pattern, which is opposite to the second type of program that we dealt with. Now similarly, let us consider this in the same way as we considered all the other programs, that is, in the form of a matrix. So here we have 5 stars in the first row, 4 stars in the next one, and 1 space. Followed by that we have 2 spaces, followed by that we have the 3 stars, and 3 spaces, 2 stars, and so on. Now let us see a practical program and try to print this particular pattern. So we are back in the practical mode, so you can see that the desired star pattern is this, and it is completely similar to our previous pattern. So the only difference is we tried to print spaces first in the earlier pattern, and here we are trying to print the stars first. So that's the only difference. And we have the same for loops. So the first for loop is for rows and it will print spaces, and the second for loop is for stars, which will print the stars. As you can see, we have the row values and the column values here as the comparator operator, and we have the comparator operator which finds if j is greater than I. In the first case, the loop will fail because the value of j and I are completely similar, because we have declared I is equals to rows in the first outer for loop and same j is equals to rows in the second inner for loop. So obviously the condition has to fail and it will not print any space here. It will directly enter into the next for loop and will print the star pattern, and followed by that we will enter into the next line. So this for loop will print the number of stars in the first row according to the row number. For example, if we give 5 as the row number, then it will print 5 stars in the first row, and it will exit the for loop and it will enter into the next line, and the same pattern will be continued. Now let us try to execute this program and see the output. Now let us give 5 as the number of rows needed. So there you go, you can see the star pattern here. So this is how this particular star pattern will be generated. Now let us move further and check out the next type of pattern program in our list. So the next type of pattern program in our list is arrow. So this arrow is completely similar to the previous one. The only difference is it is in the inverted way, which is it is pointed towards the left side. Now let us check out the practical program and learn how to execute this. Back onto Eclipse Ide. So you can find some similarities between the previous 2 programs and this particular program. In the previous 2 programs, we tried to print the first half of the pattern, and followed by that, we have printed the second half of the pattern. Now we are going to just combine both the programs and print this particular arrow pattern. So here, the first half of this particular program is concerned with the top portion of this pattern, which is the right angle triangle. Followed by that, the second half of the program where we have the conditions placed. So this particular segment of the code takes care about the second half of the program, which is the inverted right angle triangle. Now let us try to execute this program and see the output. So let us specify the number of rows as 5, completely similar to the previous 2 programs. Now let's press enter. Now there you go. Let me expand my console. So there you go. You can see the arrow pattern. So this is how you print an arrow pattern pointing towards the left side. We have also discussed an arrow pattern where the arrow will be pointing towards the right side as the program number 3. Again, don't worry about the codes. All the programs that I'm going to execute in this session are drafted in the form of a text document, and that is linked in the description box below. You can take that source file and practice the programs for yourself. Don't worry. Now let's move ahead and check out the next type of program. So the next type of pattern that we have in our list is the pyramid. We also call this an acute angled triangle star pattern. Now let us understand the logic for this. Now you can see without the matrix format, this looks completely similar to our first program, but only the difference is we have a space, which is obvious, but there is a small difference. Let us check out what the difference is. If we look this program in the form of a matrix, you can see there are variations in spaces. In the first row, we have 2 spaces, 1 star, followed by that again 2 spaces. In the next row, we have alternate space and star, space and star, and similarly in the third row we have a star, space, star and space. So this is how the matrix continues according to the number of rows provided. So let us understand how the logic exactly works for this program. Okay, so you can see the pattern that we desired is in the form of an acute angle triangle or pyramid. Now we have 2 counter variables, which is I is equals to 0 in the outer for loop and j is equals to n minus 1, which is inside the for loop. So the value of n is equals to 5, which is the total number of rows that we needed in our particular pattern. Now you can see in the outer for loop we have the condition, which is I should be less than n. So I should be less than the number of rows, which is equals to 5. Followed by that we have the post increment operator I++. So the condition will be true because 0 is less than 5 and it will enter into the inside for loop where we have j, which is equals to 5 minus 0. Followed by that we have the condition. So 5 is greater than 1. So the resultant of this particular statement is 5. So 5, which is now the value of j, is greater than 1. Followed by that we have the post decrement operator, which will decrease the value of j in every iteration. So once the statement is true, it will try to print a space. So it will print the spaces until the condition is true. So once the first for loop fails, the control will enter into the next following for loop where we have j is equals to 0 and j should be less than or equal to the value of I, which is currently equals to 0, and followed by the conditional statement we have the post increment operator, which is j++. So this particular for loop is used for printing 2 things, which is the first one star, followed by that we have a space. So once this for loop gets executed, the control will exit it and will print in the new line. So this is how the program works. Now let us try to execute this program and see the output. There you go. The program got successfully executed and the required spaces and the stars have been printed here. So as you can see, we have spaces, followed by that we have a star. Similarly, space, spaces onto the left, a star and the second star. So followed by the previous program, we have the next program, which is also considered to be like a pyramid, but the only difference is it is in an inverted format. Now let us check out the logic behind this program and try to execute a practical program. So logic wise, it's completely similar to the previous one. We have star, followed by that we have a space, and again a star, space and a star. Next row we have alternate space and star, and finally we have 2 spaces star and 2 spaces. So the number of spaces and stars is based upon the number of rows we provide. Now let us try to execute a program and see the output. Don't worry, this is completely similar to the previous one, but the only difference is it is printed in the inverted fashion. So there will be minor changes to the code. Let's try to look on those changes. So here we are back in Eclipse. So the desired pattern is here, which is an inverted pyramid, and the previous program was a regular pyramid. So here is the logic, and we have the following for loops. So the first for loop is dedicated for printing the number of spaces we require. So inside the exterior for loop we have the counter variable I is equals to 0, and I should be less than or equals to the number of rows minus 1, and followed by that we have the post increment operator I++. So let us assume that we have provided the number of rows to be 5, and according to the logic, I is equals to 0, and followed by that 0 is less than or equals to 5 minus 1, which is 4, and followed by that we have the post increment operator, which will increment the value of I to 1 once after the for loop first iteration is finished. So once the exterior for loop condition is true, the control will enter into the second for loop, which is the internal for loop, and we have the second counter variable, which is j is equals to 0, followed by that the comparator operator, which says j should be either less than or equal to the value of I. Followed by that we have the post increment operator on j. So this particular code segment, or the first part of the program, takes care about the number of spaces we require in our pattern. Followed by that we have the second for loop, which will take care of the number of stars we print and the number of spaces we require after the star pattern. Now let us try to execute this program and see the output. Now let us provide the number of rows we need. Let's provide the value as 5. Now there you go. According to the logic provided in the program, the star patterns are successfully generated, followed by the spaces. Now moving ahead, we have the next type of pattern, which is the combination of first and second pyramids. Now let us understand the logic and print this pattern. Now you can see the desired pattern is the combination of the first pyramid and the second pyramid. So the first half of the program is derived from the first pyramid pattern, and the second part of the program is derived from the second pyramid pattern. Now we have combined them together, and now we are trying to print the rhombus pattern. Now let's try to execute this program and see the output. Let us provide the number of rows as 5, and there you go. So here you can see the desired star pattern has been successfully executed. So according to the input, we have the first 5 rows, and followed by that we have the inverted star pattern, where we avoided the first row and printed the following 4 rows, so that we have a proper Rubik's pattern. Now moving ahead, we shall see the next type of pattern in our list. So followed by the previous pattern, we have the next type of pattern, which looks completely similar to the previous one. But the only difference is we have printed the second type of pyramid first and then the first type of pyramid, which makes it look like an hourglass. Now let us understand the logic and print this pattern. So here is the desired pattern what we are looking for, and this was the previous pattern what we printed. Now followed by the first segment, we have the second segment, which is dedicated to print the second half of the pattern, which happens to be the first type of pyramid, which is a regular pyramid. But the only difference is inside the first for loop, we are using the rows -1 command, because we don't want an extra star. So if we add in an extra star, this pattern will look a little abnormal. So let us try. So this is what it looks like if we had an extra star there. So let us remove it. So this is how our pattern should look like. So that's the reason why we are using row -1 here. Now let us try to execute this program and see the output. Now let us enter the number of rows we want. Let us input 5. Enter. So there you go. You can see the program got successfully executed and the desired star pattern has been printed on the console. Now let us move further and have a look on the next type of pattern in our list. So followed by the hourglass pattern, we have the next pattern where we need to print a diagonal star pattern. Now if we look at the logic, it's just a single line which is placed in the form of a diagonal. Now let us check the logic behind it. So you can see we have printed stars in the form of a diagonal of a matrix. Now we have the first 4 spaces, followed by that we have a star, and similarly 3 spaces provided by a star, then a space, and so on. Now to print this pattern, what's the logic? Let's go back to Eclipse and try to print this program. So this is our desired pattern. Now let us go into our program. Now inside the program we have 2 counter variables, which are one I, 2 is j. So the first for loop is I is equals to 1, I is less than or is equals to 5, which is the row number, then I post increment. So when the logic is true, which is 1 is less than or equal to the row number 5, the control will enter into the second for loop. So once the control enters into the outer for loop, we have the second for loop where we have our second counter variable, which is j. J is equals to 0 and j is less than 5 minus I, which is 5 minus 1, which is the current value of I, which is 4. So 0 is the value of j currently. So 0 is less than 4. Followed by that, we have the post increment on j counter variable. So once the condition is true, the control will enter into the second inner for loop and will print space. So this loop will run until the condition is true. Once the condition fails, it will come out of the inner for loop and will print a star in the new line. Followed by that, it will continue to start the outer for loop again. So this is how the flow goes ahead. Now let's run the program and see the output. So you can see the program got successfully executed and the desired pattern is printed. Now let's move ahead and understand the next type of pattern in our program. So the next type of pattern is a little bit similar to the previous one. So in the previous pattern we had one diagonal. Right now we have two diagonals which have formed the shape of X. So we can consider this as an X pattern. Now let us check out the logic, and next after that let's execute the program. So according to the logic, when we consider this particular pattern in a form of a matrix, we have the stars printed in the first row, followed by that we have 3 spaces and then again a star. So this is continued in the same way with alternate spaces, and in the third row we have a single intersection point with 1 star. So this is how the pattern should look like once the program gets executed. Now let us check out the program and see the output. So you can see on my output console, this was our previous pattern. Now what we are going to do is make a similar pattern in the opposite direction and make sure they intersect each other. Now you can see our program has 2 segments, the first segment and the second segment. They both look a little similar because the first segment will print the upper part of the pattern, that is the first V, and then the second segment will print the lower part of the pattern, which is the inverted V. Now let us check out the condition. We have the first outer loop which has the first counter variable, which is I is equals to n. N is nothing but the number of rows that we want in our pattern. Then I should be greater than or equal to 1. Followed by that we have the post decrement operator where we will decrease the value of I. Then if the condition is true, then the control will enter into the next statement where we have the inner for loop with second counter variable, that is j is equals to I. Then the condition is j should be less than the value of rows provided. Then post increment of j, and if the condition statement is true, then it will enter into the inner for loop and it will print a space. Similarly, for printing the star, we have the next segment. Inside the next segment, the condition is a little trickier because we don't want to print any stars in the space between the X pattern. We provide this condition where j is equals to 1 and j should be less than or equals to 2 times the value of I, which is the outer for loop, minus 1. If this condition is true, the control will enter inside the for loop where we have if else condition. If j is equals to 1 or j is equals to 2 into I minus 1, then we should print a star. Else we should print a space. So this will print the upper part of the pattern, and similarly we have another segment which will print the lower part of the pattern, which is the inverted V pattern. Now let's execute this program and see the output. As you can see, the program got executed. Now let us provide the value of n. Let us provide 5, and there you go. You can see that the program printed the desired pattern. So this is the first half of the pattern, which is the proper V. Then this is the second half of the program, which is the inverted V. So this is what the flow of the program is. Now let us move further and check out the next pattern in our list. So the next pattern in our list is the inverted V pattern. Now let us check out the logic behind it. If you see this in the form of a matrix, then you can recognize this. We had already discussed similar program, which was the third one, where we had printed the pyramid shape. But the only difference is we have missed out the star in between, which makes it look like a inverted V. Now let us go back to Eclipse and execute a program based on this to print this pattern. As you can see, we have our desired pattern on my screen, which is an inverted V. So if we check out the logic, we have outside loop and inside loop. So we have two for loops. So the first outer for loop has out is equals to 1. Out should be less than or equals to the number of row size, then post increment of outside variable. If the condition is true, we enter into the inner for loop where we have inner loop is equals to 1. Inner loop should be less than or equals to the row size into 2. Then we have increment operator, which is a post increment. So if this particular condition is true, then we enter into another statement where we have the if else statement. So if in value is equals to control X or in is equals to print control Y, then we should print star, else we should print a space. Now let us try to execute this program and see the output. Now let us provide the row size, which is 5. So as you can see, we have got our desired pattern. Now let us move ahead and execute the next type of pattern, which is the V pattern. Now let us understand the logic behind it. It is completely similar to the previous program, but the difference is the pattern is in inverted position to the previous one, which is in the proper V format. So now let us try to check out the code and execute the program and print the pattern. So on my screen, you can see the desired pattern what we are looking for, which is V. Now the previous program was to print an inverted V. So the complete program is same, but only there is a minor change in the logic where we have replaced I as greater than or equals to 0. And there is some change in the second segment as well. Now let us try to execute this program and see the output. So you can see the program got successfully executed and the desired pattern is printed here. The value of n or row size is equals to 5, which we have declared here in the main part. Now let us get back and check out the next pattern to be executed in our list. So the next pattern is the combination of both an inverted V and a normal V, which will result in the form of a rhombus. Now as you can see, this is our previous program. Now we have two segments in our code where we have the first segment to print the starting or the top position, which is an inverted V format, and the second segment of the code is designed to print the second half of the pattern, which is the normal V pattern. So we will combine these two and print the rhombus shape. Now let me provide the number of rows, which is 5. So there you go. You can see the desired pattern. Now let us move ahead and check out our next pattern. So the next pattern is completely similar to one of the previous ones, which is a pyramid pattern. But the difference is this pyramid is hollow, or in other words, this looks like an acute angled triangle. Now let us understand the logic behind it. So if you look at this matrix, then you can find that we are going to print the stars in the form of a side of the triangle, which is we will print the stars in the shape of a triangle and nothing inside the matrix. Now let us understand the program and print this pattern. So as you can see, the desired pattern is being located here, which is a triangular pattern. Now inside this, we have three particular for loops. So the first for loop is the outer for loop and the rest two for loops are the internal for loops. So the first internal for loop is dedicated to print spaces where we don't require stars. And the second internal for loop is dedicated to print stars where we require them. Also we have an if else condition which decides where to print a star and where not to. Now if we look at the condition, I should be less than or equal to the number of rows provided, and if the condition is true, then we enter into the internal for loop. And in the internal for loop, if j is less than the number of rows given, then in that particular location we need to print a space. Once the condition in the first for loop is failed, the control will enter into the next for loop where we have the next counter variable, that is k is equals to 1, and k should be less than or equals to 2 into I minus 1, where the value of I is 1 at the current stage. and followed by that we have the post increment of the value of k. If k is equal to 1, or I is equal to the number of rows, or k is equal to 2 star I minus 1, then we should print a star. So this will give the location in the matrix where we should print star to make it as a triangle pattern. If location is anything else than the condition provided, then we should be printing space there. Now let us try to execute this program and see the output. Let us provide the number of rows as 5. So there you go, we have printed the desired pattern. So the next pattern after the triangle pattern is the box pattern. So this particular program will be completely similar to the previous program. The only difference is we need to find the locations where we need to print stars so that the resultant pattern looks like a box. So for that we will make some changes in our program, and those changes will be related to the rows and columns. Now let us understand the logic. So as discussed before, we need to look at this pattern in the form of a matrix and check out the number of rows and columns. So where the number of row and column are equal, we need to print a star. So let us now check out the program and execute the program to print this particular pattern. So as you can see on my screen, we have the same program that we used to print the triangle, but now here we have rows and columns. So n is nothing but the row and m is nothing but the column. So if the value of the external for loop, that is I is equals to 1 and I is equals to the number of rows provided, similarly j is equal to 1, which is the internal for loop counter variable value, and if j is equals to m, that is the column value, then we should print a star in that particular location, and wherever the location does not match, we should provide a space. Now let us try to execute this program and see the output. So there you go, we have our desired pattern, which is the box pattern. Now let us move ahead and check out the next type of pattern in our list. So you can see the next pattern is completely similar to our first pattern. The first pattern was our right-angled triangle. Now we have the same right-angled triangle, but the only difference is we have used numbers here. Now we will use the numbers from our for loops and we will print the same values in our pattern so that it looks like a right-angled triangle. Now let us understand the logic. So we will see this pattern in the form of a matrix. Now we will print the numbers where we require them. Where we don't require the numbers, we will print spaces. Now let us check out the program and execute it to print the following pattern. Now you can see we have got back to our same program, but the only difference is here we are using the values of the inner for loop, which is j, instead of a star. Previously we used star symbol here, and we are now replacing it with the inner for loop value. Let us try to execute this program and see the output. Now let us enter the number of rows as 5, and there you go. We have the values of the internal for loop, making the pattern look like a right-angled triangle pattern. Now let us move further and check out on our next type of pattern in the list. So here is another right-angled triangle in our list, but the difference is we are using the numbers in a continuous manner, which is 1, 2, 3, 4, 5, 6 to 15. This type of triangle is also called as Floyd's triangle. Now let us understand the logic. So similar to the previous one, we will consider this in the form of a matrix, and we will print the numbers only where we require them, that is to form a right-angled triangle. Where we don't need the numbers, we will try to print a space there. Now let us check out the program and execute it and print this pattern. Now you can see we have got back to Eclipse, and don't get scared about the pattern. It's completely similar to the previous one. Only thing is we will be using one extra counter variable, which is k. So we have provided the value of k is equals to 1, and where we are supposed to print stars, we will add the post increment operator to the counter variable k. So whenever the for loop gets executed, we will be printing the values of k, which is 1, 2, 3, 4, 5 and so on. Now let us try to execute this program and see the output. So there you go, the values of k, 1, 2, 3, 4, 5, 6, 7 until 15. So this is how the Floyd's triangle works. Now let's get back and check out the next pattern in our list. So the next pattern in our list is similar to the previous one, which is pyramid. So this type of pyramid is also called as Pascal's triangle. Now let us check out the logic. The logic is completely similar to the pyramid's logic, but instead of star, we are going to use numbers. So this type of triangle is called as Pascal's triangle, and the logic is also a little bit different from the regular pyramid. Let us understand the logic through the code. So now you can see the program on my screen. So the logic and the for loops used are completely similar to that of the pyramid, but only the difference is we are going to print the value of number. So the number is firstly initialized as 1, followed by that we have a formula for that, which is number is equals to number into I minus j divided by j plus 1, which are the values of the counter variables of outer for loop and inner for loop respectively. Now let's try to execute this program and see the pattern. So you can see the program got successfully executed and the Floyd's triangle has been successfully constructed here. Now let us move ahead and check out the next pattern in our list. So the next pattern in our list is a box which is made up of binary numbers. Now let us understand the logic for it first. So if we look at this in the form of a matrix, we have binary numbers 1 and 0, which forms the pattern of a box. Now let us check out the program and execute the program to print this particular pattern. So you can see on my screen we have the program to print that particular box type of pattern using the binary numbers. So we have the external for loop for rows, and the counter variable I is equals to 1 and I should be less than or equal to the number of rows provided. Once the condition is true, we enter into the external for loop where we have the number, and where we have the condition I modulus 2 is equals to 0 and the number is equals to 0. And inside that we have our logic to print the binary numbers. Now let us try to execute this program and see the output. Now let me place the number of rows as 5, and there you go. We have our box pattern using binary numbers. Now let us get back and check the next pattern in our list. So the next pattern is the Ruby pattern. This is completely similar to our program where we printed the Ruby pattern using the stars. Now we'll use the numbers and print that particular pattern. Now the logic for this is completely same that of the Ruby pattern we used, but the only difference is instead of a star, we'll be placing the value of the counter variables. Now let us try to execute this program and see the output. So there you go, the program got successfully executed, and instead of stars, we have printed the Ruby pattern using the numbers. Now moving ahead, we have our next pattern. So here, the next pattern is completely similar to the first one, which is the right angled triangle pattern, but here, instead of numbers or stars, we will be using alphabets. So for alphabets, we will be using the ASCII values in the program. Let us check out that program soon. Now, first let's understand the logic. The logic is also completely similar to the right angle triangle, which we followed for stars and numbers. Now, let's check out the program. So as you can see, the desired pattern is the right angle triangle made out of alphabets. So the logic is completely true, but the only difference is we are going to print characters using ASCII values and alphabet function. Now let us try to execute this program and see the output. So the desired pattern is the right angle triangle printed using the alphabets. Now the logic is completely similar to the right angle triangle pattern, but the only difference is we are going to use the ASCII values. So we have declared an integer type variable alphabet with the ASCII value 65, which should start the alphabets from capital A, because the ASCII value of capital A is 65. Now let us run the program and see the output. So there you go, the program got successfully executed and we have the right angle triangle printed using the capital alphabets. Now let's get back and check out our next pattern. So our next pattern is a pyramid again. So instead of numbers and stars, we are going to use the alphabetical values. Now let's check out the logic. Even here you can see the logic is similar to the pyramid logic. Now let's check out the code and execute the code and see the pattern. Now you can even see the logic is also similar to the pyramid logic, but here the only difference is we are going to use the ASCII value, that is 65, which is equivalent to capital A. Now in the print statement, instead of a star, we are going to print the alphabets, and this particular for loop is for spaces. Now let's quickly execute this program and see the output. So there you go, the pyramid pattern has been successfully printed. At first, we will start with the beginner level interview questions. So in the beginner level interview questions, the first question we have is, what is JIT? So the answer for this question is, JIT is an abbreviation for Java In-Time Compiler. It increases efficiency of the interpreter by compiling the bytecode in the runtime. JIT, or Just-in-Time Compiler, compiles code to machine level directly for higher speeds of code execution. So basically, just-in-time compilation is a feature added to the interpreter of Java. So this involves conversion of the code directly to machine level during the compilation stage. This improvises the speed of execution of a Java program. Now after the first question, the second question in the docket is, what is a class loader? Now let's discuss the answer for this particular question. So basically, class loader is the first file to load when you execute any Java program. So the Java class loader is the integrated part of Java virtual machine. So the functionality of class loader is to load the class to the Java virtual machine while it is demanded to execute a class. Java has bootstrap, extension and application type of class loaders. So the third question in the docket is, what are the memory allocations available in Java? So the answer for this particular question is, Java provides multiple types of memory allocations, but the 5 major types of memory allocations which are most frequently used are class memory, heap memory, stack memory, program counter memory, native method stack memory. So the next question in the list is, will the program run if I write static public void main? So basically we write public static void main, but in case, imagine if I write the program as static public void main, will the program execute properly? So the answer for this question is yes, because Java does not follow any specific rule for the order of specifiers you place in your program. So when you execute the program with such pattern in your specifiers, then the program will compile successfully. Also, it will run successfully. So the next question we have is, what is the default value stored in local variables? So in C programming language, when you declare a local variable or a global variable or any type of variable, then the first value which is stored inside that variable will be a garbage value, unless you initialize the variable with a personalized value. For example, if you declare a variable I equal to 0, then you are storing a value in that variable I, that is 0. If you just declare it as int I, then the value stored inside that I variable will be a garbage value. So similarly, when you declare some kind of local variable in Java, then what will be the default value stored inside it? So the answer for this question is neither the local variables or the global variables or any primitives or any object references do not have any kind of default value stored in them. So followed by the fifth question, we have the sixth question. So what would be the output of the following code segment is the sixth question. So this might happen sometimes. So basically what happens is your interviewer will throw a question at you which has a code segment. So all you need to do is decode that code in your mind and provide the output. So this would be the code that we will be dealing with. So you can see our question has two printf statements. The first one has 100 plus 100 plus a string which is Simplilearn, and in the second printf statement we have a string that is e-learning company plus 100 plus 100. So what will be the output of these two printf statements? So the answer for this question is really simple. So we'll be having 200 Simplilearn as the first output and e-learning company 100 as the second output. Why? Let's check out the code segment once again. So when you see the code segment once again, so the first printf statement has 100 plus 100 plus Simplilearn. So JVM here understands 100 as an integer value and the plus symbol as an addition operator here. So followed by the addition operator, we have another integer value. So what JVM does is it adds the two numbers 100 plus 100. So followed by that we have another plus symbol here. So followed by the plus symbol we have a string value. So here the JVM considers the plus symbol as a concatenating operator but not as an addition operator. So that's why the first two numbers got added and the result was 200 and the next two values were concatenated. So it became as 200 Simplilearn. Similarly, in the second printf statement, the JVM encountered with a string value. So it considered the plus symbol as a concatenating operator. Similarly, it happened with the second plus symbol as well. So that's the reason we had e-learning 100 as the second output. Now followed by the sixth question, we have the seventh question. What is an association? So the answer for this question is an association can be defined as a relationship that has no ownership over the other. So to understand this definition, we can consider a simple example. Consider a person associated with multiple banks. So consider person X who has got accounts in bank A, bank B and bank C. And similarly, a bank is associated with person X. That is, a bank A, bank B and bank C are associated with the person X. But no one has ownership over the other. A person X who is an account holder with all the three banks, that is A, B and C, does not possess any kind of ownership over the three banks. Similarly, banks A, B and C who has the customer, which is the person X, but the banks do not possess any kind of ownership over the customer. So the relationship between the person X and the banks ABC can be considered as an association. Now followed by the seventh question, we have the next question, that is the eighth question. Define copy constructor in Java. So the answer for this question is as follows. A copy constructor in Java is a constructor that initializes an object through another object of the same class. A copy constructor in Java is really helpful because when you want to copy a complex object that has several fields, or when we want to make a deep copy of an existing object, then the copy constructor is the one which will help you out in this situation. So followed by the eighth question, we have the ninth question. What is a marker interface? So the answer for this question is an empty interface in Java is referred as a marker interface. Serializable and clonable are some of the popular examples of marker interface. So basically a marker interface is just another interface, but normally in interface we provide some signatures. So these signatures belong to particular methods. So in normal interface we just have method signatures but not the complete implementation, or at least we'll be having some variables. But in a marker interface we do not have any kind of data manipulating method signatures, any data members, nothing. They have special functionality unlike a normal interface. So followed by the ninth question, we have the 10th question. What is object cloning? I guess the word object cloning is completely self-explanatory, yet the answer for this question is, it is an ability to recreate an object completely similar to the existing object. This process is known as object cloning in Java. Java provides a built-in function or method, that is the clone method, to clone an existing object, offering the same functionality that of the original object. So followed by the 10th question, we have our 11th question. Why is Java not completely object-oriented? So this question might be a little confusing, but it's true. Java is not completely object-oriented. But what's the reason? Yes, I'll explain you why Java is not completely object-oriented. So the answer for this question is, Java is not considered as 100% object-oriented programming language because of the data types it uses. it still makes use of 8 or more primitive data types, which are int, float, double, and few others. So this is the only reason why Java is not considered as completely 100% object-oriented programming language. So the next question is, define wrapper classes in Java. So the answer for this question is, in Java, when you declare primitive data types, that is the int, float, double, etc., then the wrapper classes are responsible for converting them into objects or reference types. Just as we discussed before, Java is not 100% object-oriented programming language just because of the primitive data types it uses. So when you include such primitive data types, then wrapper classes are the ones which convert them into objects or reference types for the ease of compilation and execution of programs without any issues. So followed by this question, we have the next question. Define singleton classes in Java. So the answer for this question is, in Java, when you make the constructor of a class as private, then the particular class can generate only one single object. This is the reason why such type of classes are called as singleton classes. So followed by that, we have our next question that says, define package in Java. So if you use some of the popular IDEs, that is the integrated development enterprises such as Intellij or Eclipse, then you might be familiar with projects, packages, source files, and then the class file. So basically you create a project first, and inside the project you will be having your source folder, and then you will be creating your own package using the source folder, and inside the package you will create a class file, and inside the class file is where you write your Java program. So here the question is, define package in Java. So the answer for this question is as follows. Package is a collective bundle of classes and interfaces along with necessary libraries and jar files. The use of packages helps in code reusability. So basically when you create a specific package, inside that package you will store all the class files that you will be using in your Java program. So not only class files, in case if you use any kind of connectors or any kind of jar files or any kind of dependencies for your Java program, you will include all those inside the package so that the requirements and the class files are bundled together, and this helps out in code reusability, making sure that the program files or the jar files or any dependencies are not juggling between one package to the other or one file to the other. So using a package is basically a good practice. So followed by this, we have our next question. Can you implement pointers in Java program? So if you remember C programming language, we had pointers there. So we use pointers to directly access the memory. So similarly, can you use pointers in a Java program? This is a little tricky question for beginners, but basically it's really simple. Now the answer for this question is no, because Java Virtual Machine personally takes care of memory management implicitly. So Java's major motto was to keep programming simple. So accessing memory directly through pointers is not a recommended action. So the answer is a big no, you cannot implement pointers in Java program. So followed by that, we have our next question. Differentiate between instance and local variables. So the answer for this question is really simple. Instance variables are declared inside a class and the scope is limited to only a specific object inside which an instance variable is created. So followed by the instance variable, we have the local variable. So the local variable can be anywhere inside a method or a specific block of code. Also, the scope is limited to the block of code where the variable, that is the local variable, is declared. Now followed by the 16th question, we have our next question. Explain Java string pool. So the answer for this question is a collection of strings in Java's heap memory is referred as Java's string pool. So for example, you wanted to create a new string. Consider your name. So your name might be some XYZ. So if you wanted to create XYZ string, then you provide that particular code to your JVM. So what does JVM do? It will not directly create that particular string. First, it will search for the XYZ string in your string pool. If that is already existing in your string pool, then it will provide a reference to that particular string. In case if XYZ is not there, then the JVM will create a new string, that is the XYZ string. So followed by this, we have our next question, that is, what is an exception? So the answer for this question is, an exception in Java is considered as an unexpected event that can disrupt the normal flow of the program. So for example, just consider that you are going to write a program for division operator. So after you finish your program, your evaluator might want to test your code to the extreme levels. So instead of providing a proper number, imagine that your evaluator is providing a wrong input, such as special symbols, sometimes 0 or any other sort of input. So if this kind of input is provided to your program, then your program might crash. So you can avoid this kind of crash by using exception handling. So basically you can use try and catch blocks. So you can embed your code inside the try block and say to your program that if any kind of wrong input such as special symbol or 0 is provided by the evaluator, then send a message saying wrong input or divide by 0 exception. So this kind of approach will provide an output, but this kind of approach will avoid your program from crashing. So this is how exceptions are handled in real time. So followed by this, we have our next question. What is final keyword in Java? So the answer for this question is, the term final is a predefined word in Java that is used while declaring values to variables. When a value is declared using the final keyword, then that particular value of that particular variable will remain constant throughout the execution of program. So sometimes if you include a normal variable and provide an operation on that particular variable, then the value of that particular variable will change after the execution of program. But when you declare the same variable using final keyword, then no number of operations or any kind of manipulations applied onto that variable will not change the value of that particular variable. So that's the speciality of final keyword in Java. So followed by that, we'll dive into the next question, that is, what happens when the main method is not declared as static? So the answer for this question is, when the main method is not declared as static, then the program may be compiled perfectly, but ends up with a serious ambiguity and throws a runtime error that says no such method error. So when you basically declare a main method, don't forget to specify the static keyword. So with this, we finish the beginners segment of questions. Followed by the beginners segment, we have the next segment, that is the intermediate level segment. So the first question in the intermediate level is, what is JDK, and mention the variants of JDK. So the answer for this question is, so JDK is basically an abbreviation for Java Development Kit. This is a combined package of JRE, that is the Java Runtime Environment, and developer tools used for designing Java applications and applets. Oracle has the following variants for Java Development Kit. So the first one is the JDK Standard Edition, which is normally used by beginners and intermediate developers. Next, after the JDK Standard Edition, we have the Java Development Kit for Enterprise. So this particular Enterprise Edition is used by professional Java developers for developing Java-based applications and frameworks. Now the last one is the Java Development Kit Micro Edition. Now followed by 21st question, we will dive into the next question that says, brief access specifiers and types of access specifiers in Java. So the answer for this question is as follows. Basically, access specifiers are predefined keywords used to help a Java virtual machine to understand the scope of a particular data member or data manipulating method within a class or outside the class. So in Java, we have 4 types of access specifiers. The first one is public access specifier. So when you declare a data member or a data manipulating method as public, then that particular data member or method can be accessible by any class or object throughout the package. Followed by that, we have the private access specifier. So unlike the public access specifier, when you provide the private access specifier, then the accessibility of that particular private data member or the data manipulating method will be provided to specific classes and specific objects only. And finally, we have the protected access specifier. So the protected access specifier is a bit more secure than the private access specifier. So the access for this particular protected data member or protected data manipulating method could be a little more difficult to access unless you are going to implement everything which is present in that particular package. So basically, if you are trying to access the protected data member or protected data manipulating method of a different package, then you need to first import the package into your existing package. So that's how the protected access specifier works practically. So finally, after the major 3 access specifiers, we have the default access specifier. So default access specifier will be provided by the Java virtual machine. So in case if you declare a variable or a data manipulating method without using any specific access specifiers that are public, private and protected, then JVM implicitly considers the default access specifier. So there is no much of a difference between the public access specifier and the default access specifier. Both have the same functionality and accessibility. So followed by this question, we enter into the next question, that is, can a constructor return a value? So the answer for this question is as follows. Yes, a constructor can return a value. It basically returns the current instance of a class implicitly. You cannot make a constructor return a value explicitly, but automatically it returns the instance of a class. So the next question is, explain this keyword in Java. So in Java, we do have a keyword which is called as this. So what does the keyword this mean in Java is the question. So the answer for this question is, the term this is a special keyword designated as a reference variable. So the term this keyword is used to refer to the current class properties like data manipulating method, instance, data member and constructors. So followed by the 24th question, we have our next question that says, explain super keyword in Java. So the answer for this question is as follows. The term super is a special keyword designated as a reference variable. So similar to this keyword, even super keyword acts as a reference variable. But the difference is super keyword is used to refer to the immediate parent class object. So followed by the 25th question, we have our next question, that is, explain method overloading in Java. So basically method overloading and method overriding etc. are the concepts of polymorphism. So now let's have a correct answer here. So the process of creating multiple method signatures using one method name is called as method overloading. So for example, consider that you wanted to include an addition operation in your program that performs addition operation. So the first method will be having the name add, and inside the method parameters, you'll be having 2 integer types of parameters. Similarly, you wanted to perform another addition operation with the same name add. So here you will provide the method name completely same to the first method, but inside the parameters there is a difference. You are adding 3 parameters here. So when you pass the values to the add method, then which method to be overloaded? That's the confusion, right? So should I overload or should I execute the first add method or the second add method? So this completely depends on the number of parameters you pass. If you are passing 2 parameters, then the first method will be executed. If you are passing 3 parameters, then the second method will be executed. So this is how the method overloading happens in Java. So the process of method overloading can be achieved by using 2 different ways. The first way is to change the number of arguments. So that's what exactly I've discussed before. Now the second way is varying the return type of the method. So with this, let's enter into the next question. Can we overload a static method? So as discussed before, the values of the variables or data manipulating methods will not be changed when we have used the keyword static in front of it. So the question is, can we overload a static method? Now let's discuss the answer for this. The answer is no. Java does not support overloading of static method. The process would throw an error reading static method cannot be referenced. So followed by this, we have our next question. So the next question is, define late binding. The answer for this question is, binding is a process of unifying the method call with the method's code segment. Late binding happens when the method's code segment is unknown till the method is called during the runtime. So followed by this, we have our next question. Define dynamic method dispatch. So the answer is, the dynamic method dispatch is a process where the method call is executed during the runtime. The overridden method is called through a reference variable of superclass. So this process is called as runtime polymorphism. Now we have our next question. Why is delete function faster in linked list than an array? So basically, linked list and array are the Java collections, or in other words, it's also considered as data structure. So to answer this question, you need to understand the analogy of linked list and array. So basically, an array is a complete memory block of consecutive memory locations. So consider that your memory location starts from 100 and your array has 10 locations. So it's a complete reserved block of from 100, 101, 102 to 109. So you have 10 memory blocks. So in case if you wanted to add a number or delete a number, then you had to make changes to the complete memory block. But when you come into linked list, you have the memory blocks used from the memory heap. So basically what you do here is you basically connect the nodes through addresses. So in case if you wanted to eliminate a number, then what you do is just to manipulate the addresses. So the address of the consecutive node will be changed. So that's the only change what you make. So now this is the reason why the delete function or any kind of manipulation function is faster in linked list compared to array. So now let's have a brief answer on this. Delete function is faster in linked list as the user needs to make a minor update to the pointer value so that the node can point to the next successor in the list. Now followed by this, we have our next question. Give a briefing on the life cycle of a thread. So the life cycle of a thread includes 5 stages, which are as mentioned below. Newly born state, runnable state, that is, it provides the JVM with a feedback that I'm ready to run now, followed by that the running stage where the thread is actually running, followed by that the block stage. So basically the thread will be blocked for some reasons, for some intermediate output or something, if the thread is waiting for an input from another source or something similar. So that's where the blocked state comes to existence. And finally the dead state. Once after everything is processed, the thread is eliminated by JVM. Now followed by this, we have our next question that says, explain the differences between the operators provided here. So the operators might look similar, but they are different. Now let's understand about these operators in a much better way through the answer. So the answer for this question is, although they look similar, but there's a huge difference between them. So the first operator, which looks like two greater than symbols, perform the operation of right shifting. So when you provide a binary number or binary value, then the bits will be shifted towards the right. And the second symbol or the second operator, which is having three greater than symbols, is used to shift out the zero filled bits. So this is the functionality of these two operators. Now followed by that, let's have the 33rd question. Brief the life cycle of an applet. So the answer for this question is, the life cycle of an applet basically involves the following stages. The first stage is the initialization stage, next is the start stage, third is the stop stage, fourth is destroy, and finally we have paint. Now the next question is, why are generics used in Java? So the answer for this question is, compile time type safety is provided by using generics in Java. So this approach allows the users to catch unnecessary invalid inputs at the time of compilation. Generic methods and classes help programmers to specify a single method declaration, a set of related methods, or with a single class declaration, a set of related types. So followed by this, we have our next question. Explain externalizable interface. So the answer for this question is, the externalizable interface helps with the control over the process of serialization. The externalization interface incorporates read external and write external methods. So we have listened to a new term here, which is serialization. So what exactly is serialization? Serialization is a process of sending your Java code or Java project from one computer system to a different computer system. So basically, if you wanted to execute some kind of Java program from a different location, then you serialize this particular code to a different location where you actually want to execute, and this particular process of transferring your code is called as serialization. Now the next question is, explain daemon thread. So the answer for this question is, the daemon thread can be defined as a thread with least responsibility. The daemon thread is designed to run in a background during the process of garbage collection in Java. The setDaemon method is used to create the daemon thread in Java programming language. So we have our next question now. Explain the term enumeration in Java. So the answer for this question is, enumeration or enum is an interface in Java. Enum allows the sequential access of elements stored in a collection in Java. Now the next question is, why is Java considered as a dynamic programming language? So the answer for this question is, Java was designed to adapt to an evolving environment. Java programs include large amount of runtime information that is actually used to resolve access to the objects in real time. So this is the reason why Java is considered as dynamic programming language. Now followed by this, we have our next question. Can you run a code before executing the main method? So the answer for this question is, yes, we can execute any code even before the main method. We will be using the static block of code in the class when creating the objects at load time of the class. Any statements within the static block of the code will execute it once while loading the class, even before the creation of objects in the main method. Now the last question in the intermediate section is, how many times the finalized method is called? So the answer for this question is, the finalized method is called by the garbage collector. So for every object, the garbage collector calls the finalized method just for once. Now with this, let's enter the advanced segment of interview questions based on Java. So the first question in the advanced segment is, can the keywords this and super be used together? So the answer for this question is, no. This and super keywords should be used in the first statement in the class constructor. So the following code segment will give you a better idea. So you can see that we have used the keyword super and this in the class constructor. That is the first class constructor. Now this is how you can use super keyword and this keyword together in case if you wanted to use. So with this, let's continue with the next question in the advanced level. So the next question says, explain JSP page. So the answer for this question is, JSP is basically an abbreviation for Java Servlet page. So the Java Servlet page consists of two types of text. The first is the static data and the second one is Java Servlet page elements. Now the next question is, explain JDBC. So the answer is, JDBC is an abbreviation for Java Database Connector. JDBC is an abstract layer used to establish connectivity between any existing database and to a Java application. Next question is, explain the various directives of JSP. So the directives are instructions processed by JSP engine. After the JSP page is compiled into a servlet, directives are used to set page level instructions, insert data from external files and specify custom tag libraries. Directives are defined between the following symbols. So these are the symbols that are used to specify the directives in a JSP page. The different types of directives are shown as below. There are three types of directives. They are include directive, page directive, and taglib directive. So include directive includes a file and merges the content of the file with the current page. The page directive is used to define specific attributes in the JSP page like error page and buffer. The taglib directory is used to declare a custom tag library which is used in the JSP page. Followed by that we have the next question. What are observer and observable classes? So the answer for this question is, objects that subclass the observable class maintain a list of observers. When an observable object is updated, it invokes the update method of each of the observers to notify that the observers that it has changed its state. The observer interface is implemented by objects that observe observable objects. Might be a little confusing, but you need to read this answer once again. You can pause it and you can read this answer once again so that you can get a brief understanding of this. Followed by that we have the next question. What is session management in Java? So the answer for this question is, a session is essentially defined as the dynamic stage of a random conversation between the client and the server. The essential communication channel includes the string of responses and requests from both sides. Typically, the most popular way of implementing session management is the employment of a session ID in the communicative discourse of the client and the server. The next question is, brief about Spring Framework. Spring Framework is basically the framework of frameworks. Now, the answer for this question is, Spring is essentially defined as the application framework and inversion of control container for Java. Basically, the chief purpose of Spring Framework is to create enterprise applications in Java. Also, it is especially useful to keep in mind that the central features of the Spring Framework are essentially conducive to any Java application. So the next question is, explain JCA in Java. So the answer for this question is, JCA is basically an abbreviation for Java Cryptography Architecture. So JCA provides a platform that gives architecture and APIs for encryption as well as decryption. JCA is used by the developer to combine the application with the security measure. It also helps in performing the third-party security rules. It uses the hash table, encryption message digest, etc. to implement the security. So the next question is, explain JPA in Java. So the answer for this question is, JPA stands as an abbreviation for Java Persistence API. The JPA is enabling us to create the persistence layer for desktop and web applications. JPA deals with the following: Java Persistence API, Query Language, Java Persistence Criteria API, Object Mapping Metadata, etc. So the last question in our list is, explain the different authentications in Java servlets. So the answer for this question is, Authentication options available in servlets are as follows. The first one is basic authentication. So the basic authentication consists of username and password provided by the client to authenticate as the user. The second one is form-based authentication. In this particular type of authentication, the login form is made by the programmer by using HTML. Followed by that, we have the third type of authentication, that is digest authentication. Digest authentication is similar to basic authentication, but in this the passwords are encrypted using hash formula. This makes digest more secured. And lastly, we have the client certificate authentication. The client certificate authentication requires that each client accessing the resource has a certificate that it sends to authenticate itself. This requires SSL protocol.
Hello guys, this is Vikesh and let's get started with today's topic, which is about walking through a particular project using all the concepts which we have learned so far. So in this session, we are going to focus on a particular project, and the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using the scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to PIN mapping. So we create a map, and inside the getLogin method, we add couple of entries to the map. Here, the first entry, the first integer, is pointing to the customer number, and the second integer is pointing to the PIN of the account of this particular customer number. So if we call the getLogin method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called setCustomerNumber. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks. But things get interesting in this method. So what we covered so far was the getLogin method. Let me close this method here. So we covered the getLogin method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here based on the customer types 1, 2, 3, or 4. The corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund, and for that also I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number, PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes, where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input which will be used at multiple places, and then I have the setters and getters for these four member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have said that, we were fetching the values using the get customer number and the get PIN number, and that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these two methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have two methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have two more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit. Basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the getLogin method. Remember, getLogin was the first method which asked you to provide the customer number, and then getLogin called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the getAccountType, and the getAccountType method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the getChecking method. And the getChecking method again provides you with another menu, view, withdraw, or deposit, or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option, because inside the getChecking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class, and this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw, so I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100, and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here getChecking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise, your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application. And this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application, and this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the getResult, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9, the current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the getResult based on the expression. And whatever result we get from the getResult, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the getResult for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by 0 scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts.
So why Kotlin? Kotlin is one of the fastest growing and widely used programming language. In May 2017, Google announced it as an official language for developing Android applications. After this announcement, the jobs for Kotlin increased in large numbers. Since then, the job openings for Kotlin gets doubled every 3 months as per DICE. It is very easy and friendly language. Also, it is quite easy to maintain and debug this language, which is why it is a good language to start with. Kotlin has a bright future as it is being widely used for Android development. Companies like Google, Netflix, Pinterest are some of the companies using Kotlin. So being a Kotlin developer will boost up your career growth. Now, coming to what is Kotlin? Kotlin is an open source statically typed language designed by JetBrains. It has both the features of object-oriented programming and functional programming. Kotlin is interoperable with Java. That means both the languages can share and use the information, and just like Java compiler, the Kotlin compiler also generates the bytecode which can run on JVM. Also, we can say Kotlin is kind of Java with some added features. Even the Java libraries can also be used in Kotlin project. Although Java is a really cool language, the developers of Kotlin focused more on simplifying the code and increasing the transparency. Now, let's learn some history of this Kotlin language. The development of the Kotlin language was announced in the year 2011. In 2012, the first web demo of Kotlin was released along with the new logo and became an open source. Then in 2014, kotlinlang.org was released along with some features to increase the interoperability with Java. In the year 2015, some new features were added like the companion objects, multiple constructor, etc. After a quite long development process, Kotlin 1.0 version was released in February 2016. It was developed by JetBrains in Russia. The developers of JetBrains were fed up with the repetitive code, so they wanted a much modern language. But the problem was most of their code was already written in Java, and switching to some other language would create a bigger headache for them. So the team decided to create a language which is compatible with Java and with all the features they wanted. So then they created the Kotlin language. In the year 2017, Google announced the first class support for Kotlin on Android. Later, Kotlin 1.2 was released with features like sharing code between JVM and JavaScript. After that, various versions were released like Kotlin 1.3 in 2018, Kotlin 1.4 in 2020, Kotlin 1.5 in 2021, etc. Now, moving on to features of Kotlin language. The first feature is Kotlin language can be used on multiple platforms, which reduces the time that is spent on writing and maintaining the code on different platforms. Kotlin doesn't depend on virtual machine on the target platform. Next is Kotlin has some modern features like null safety, which is a feature to reduce the problems associated with the null references. Then the Lambda function, which is an anonymous function, and the smart casts, which are used to track conditions inside the if expression. Next is, in Kotlin language there are many extensions which allows us to add the functionality without inheriting from the class or any decorative pattern. This feature makes the code easy to maintain and read. Now coming to another feature of Kotlin, which is in Kotlin, functions can be passed as parameters to the function. That means function act as a variable, and just like the variable, it can also be passed. It is also known as higher order function. Its functionality is to do two things. First, to take the functions as parameters, and second, to return a function. Next feature is Kotlin is compatible with Java. It is fully interoperable with Java, and you can convert the Java file to the Kotlin file with just a script. Also, it works on JVM, and Java libraries work fine on Kotlin. Next is, in Kotlin there is a data class. A data class is that class which doesn't perform any operations and only contains state. The advantage of this class is that it provides self-generated code and avoids the implementation of methods within the class. Now, coming to uses of Kotlin. Kotlin is used in web development. It is compatible with Java and also much easier to work with. Also, Kotlin works fine with Spring and some other frameworks, which makes it an easy replacement of Java when it comes to web development. Next is, Kotlin is used in data science as well. Because of its features like null safety, statically typed, maintainable code, and also being a language which runs on JVM makes Kotlin a good choice for working with the data. Next is, it is used for Android development. After Google has announced Kotlin as the first class language, the users' interest in Kotlin language elevated to a great extent, which resulted in creating a large community of Android developers going for Kotlin. This language allows the developers to write more expressive and concise code, and its interoperability with Java is one of the main attractions to choose this language. With Google's statement, not only the Android developers but also the app development companies are opting the Kotlin language. Similar to these uses, there are many more uses to the Kotlin language. But now, let's move on to its applications. So we'll start with Google. Google widely uses the Kotlin language. Not only they have declared it as the first class programming, but they also use it in their production code. Google also implemented Kotlin in more than 60 applications, such as Google Home, Google Maps, Google Drive, Google Pay, Google Sheets, etc. Similarly, Airbnb, which is an American company that operates online marketplace for lodging and homestays to vacation rentals, also uses Kotlin language for their Android frameworks MVRX for a seamless experience. Other companies like Zomato, which is India's largest food delivery company, also uses Kotlin for the Android app, which has helped them to reduce the lines of code and made the code a lot more concise. Next is Netflix. Netflix is world's leading streaming service, also used the Kotlin language to rebuild their UI player for the Android app of Netflix. Next is Uber. The American mobility company Uber that provides services like food delivery, ride-hailing, package delivery, couriers, etc. uses Kotlin language because of its popularity for Android development and its interoperability with Java. So these were some popular companies that uses the Kotlin language. Similar to these companies, there are many more companies like Pinterest, Tinder, Slack, etc. that uses this language. Now, let's have a look at what we have learned so far. In this video, we spoke about why Kotlin language, what exactly Kotlin is, then history of Kotlin language and some of the features and uses of Kotlin language. And at last, we have covered the companies that uses Kotlin language.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Kotlin is a general-purpose, statically typed programming language developed and released by JetBrains in 2016. In 2011, JetBrains revealed the Kotlin project, which is a new language for JVM. And later, in February 2016, its first version, Kotlin 1.0, was released. This language is concise and more expressive than Java. It is fully interoperable with Java, and it is also said that Kotlin language is made by extracting all the good parts of different programming languages like Scala, JavaScript, Java, C#, etc. Google also announced Kotlin as the first class language for Android development. So it is now an official language for the development of Android, and is being opted by many organizations across the globe. Now let's move on to our next topic, which is variables in Kotlin. There are two types of variables in Kotlin, which are var and val. First, var. The var variables are mutable, which means their value can be reassigned. Then there is val. The val variables are immutable, which means their value cannot be reassigned or changed or modified. As we can see in the example, var is the type of the variable name and the value Raj is assigned to it. After that, the value is reassigned as Sid. So after printing, it will display Sid because var is mutable type and its value can be reassigned. On the other hand, val is the variable whose value cannot be reassigned, which means it is immutable. As we can see in the example, on printing the value of the name variable, it is showing an error because we tried to change or reassign the value from Raj to Sid. And because it is a val type variable, the value is not going to change. Kotlin is smart enough to understand which is string and which is an integer. So it is not necessary to specify the type. Like in this example, name is the string and roll number is the integer. But we haven't specified their type, and still there is no error. However, it is possible to specify the type if you want. Now, coming to next topic, which is string templates. A string can be defined as a collection of characters enclosed in double quotes. The string templates allows us to include the expressions, variable references inside the string. The references in a string start with a $sign. To print the string, we need to add the $sign before the string name. We can easily add the variables in the string instead of concatenating them. For example, here name1 and name2 are two strings and we can include them together within the same sentence while printing like both $sign name1 and $sign name2 are best friends. It will display the value of string within the sentence. We can also print the expression like we did while printing the second sentence, dot to uppercase. Dot to uppercase is an expression, and in Kotlin expressions start with a $sign and are enclosed in the curly brackets, as we can see. So as we have understood about the string templates, let's move on to if, else and when statements. If is used with a condition. If that condition is true, then the block of code executes. And if the condition is not true or false, then the else block executes. Now in Kotlin language, the if-else statements can also be used as expressions. That means they can return a value. While using if-else as an expression, it is mandatory to use the else branch. Here in the example, we can see if A is greater than B is the expression and the value of that expression is assigned to the variable named great. Now, whichsoever is greater among them, that will be assigned to it and is then printed. Now, coming to when statements. When statements in Kotlin is similar to switch statement in Java. When statement is used to select one code block from the multiple code blocks based on a conditional expression. The code block which satisfies the condition is executed. For example, as you can see, the value 4 is assigned to the variable tab. Now, whichsoever value matches with the value of tab, that particular code block will execute. In this case, there are no code blocks but single line branches. The branch value that matches with the value of tab, that particular branch will execute. Like wrap will execute, which is then stored in the order variable, which is then printed. Now, let's move on to arrays in Kotlin. Arrays are generally used to store multiple values in contiguous memory location in a single variable. In Kotlin language, to create an array, you have to use the address of function and then write the elements inside the bracket. For example, here name is the array name and Sid, Robbie, Max, John are the elements of the array. In order to print the elements of the array, you can use loops. For example, here we are using for loop. In this for loop, n is the variable, names is the array name, and one by one it will print every element of the array. Now, as we have understood about arrays, now let's understand about loops. Loops are used to iterate through the different parts of program. For example, arrays, ranges several times. It is a set of instructions which keeps on repeating until a certain condition is met. It is generally used while working with arrays. In Kotlin language, the for loop is a bit different to that in Java. In this for loop, we use a variable in operator and the array name to display the elements of the array. For example, as you can see in the example, there is an array with elements 4, 2, 5, 12, 7, and using the for loop, we are displaying the elements of the array inside the for loop. Here n is the variable, in is the operator, and numbers is the array name. Loops are also used to iterate through the ranges, which we will discuss later. Now, let's understand while loop and do while loop. Both these loops are similar to the loops in Java. The function of the while loop is it checks the condition and executes through the block of code as long as the specified condition is true. And the do while loop executes the do block once before checking if the condition is true, which means the loop will execute at least once even if the condition is not true. So as we have understood about loops in Kotlin, so now let's move on to our next topic, which is null safety. So null safety is a feature in Kotlin language that solves the problem of null pointer exception. If you have worked on other languages including Java, then you must have an idea of null pointer exception. In Kotlin language, you can easily create null type variable. To create a null type variable or string which can hold a null value, we can simply define them by putting the question mark at the end. As we can see in the example, name is the variable name and string is the type, and after string there is a question mark, which means that this variable is of null type. By default, all the variables are not null in Kotlin, but you can create one by putting a question mark with them. Now, moving on to the next topic, which is ranges. Now, ranges can be defined as an interval from start to end. Expressions are created with double dot operator and an in operator. Here in the example, 0 is the starting point and 7 is the ending point. In between them, there is operator, double dot operator, which means that the loop will iterate from 0 to 7. Similarly, we can also print the range with gaps like in the example, I in 0 to 10, step 2, means that it will print from 0 to 10 with a gap of 2 digits like 0, 2, 4, 6, 8, 10. Range can also be used in decrement manner. For example, I in 7 down to 2 means the loop will iterate from 7 to 2 in a decreasing order. Now, let's move on to the next topic, which is Kotlin functions. Functions are also known as methods. They are the block of code which runs whenever it is invoked. In Kotlin language, functions are defined with the fun keyword. After that, the name of the function and parentheses are written. If the parentheses are empty, it means function doesn't accept any arguments. In function with parameters, the parameters are specified inside the parentheses. the type of parameter is specified after the name of the parameter. As we can see in the example, fun is the name of the function, num1, num2 are the parameters name, int is the type of the parameters, then after that the colon, there is another int data type, which is the return type. That means it is the data type of the value which is returned. So these were some important topics of Kotlin language. Now let's go to the code editor and do some practical implementations. So this is our IntelliJ idea. Here we will do some examples of Kotlin language. So let's go ahead. First of all, we'll create the Kotlin file. So let's name it as example1. So first we'll do an example of string template in which we'll have a look that how to create those strings and how can we use some expressions with them. So let's start. So fun is the keyword for function. Now main function. Now inside this main function we'll write val. This is immutable as we know. Code is the name of the variable. Now let's say code is cipher. In Kotlin language you don't need to put the semicolon in the end as it is not necessary. You can do it, but it is not necessary to do that. Alright, now after that let's say we want to print this. We'll write the code is $code. So this is how we can print this string, and let's see that if it works or not. First of all we'll have to save it. So we'll do save all, and now we'll go to run. Now here we will on run and select example1. Alright, as you can see the code is cipher. It is getting printed. Now let's say we want to use some expression with it. Right, the code is, let's say we want to write the code in capital letters. We'll write the code is $, and then the curly brackets, and inside the curly brackets we'll write code dot uppercase. Yes, uppercase, now with brackets. Now after that, if you want to put the semicolon, it is your choice, otherwise it is not required. So now let's save it again. Save all, and now let's try to run it. As you can see, the code is cipher, the first one, the code is in capital letters, cipher. So this is how we can do it, and we can also merge the strings. We don't need to concatenate them. So we can do like this, the code is this, and right. Now let's try to run it again. So here what we are doing is we are merging the uppercase and lowercase. Here we can see the code is cipher and cipher. So this is how we can concatenate both the strings easily. So this is one of the example of string template. Now let's do another example of if-else statements as expressions. Let's go ahead. Right, now we'll create main class fun main, and inside this main function, first of all we'll create two variables, that is marks1 of val type
and let's assign it value 87. Then another variable marks2, and we'll assign it as, let's say, 82. Here we are using if-else as expressions. So what we'll do is we'll make a variable result and we'll store the value of if or else in that particular result, and then we'll display that particular variable. And let's say that variable is result. Here we will use if-else as expressions. So val result equals if marks1 is greater than marks2, then in the bracket write marks1 equals, this is for the printing purpose, $sign marks1 is the greater among both. Now let's write is greater than marks2. Variable marks2. Alright, now similarly we'll do for else as well. We'll write else now similarly we'll write marks2 equals marks2 variable is greater than marks1. Alright, so after that we'll print the variable result, because the result is getting stored in this variable result. So whichever is greater will get stored over here, and then we will print this variable, print ln, and we'll write result. Alright, now it's done, and I think we have to run this one. Save it and let's try to run. Example 2. Hope it works. As we can see, marks1 87 is greater than marks2 82. As marks1 is 87 and marks2 is 82, so marks1 is greater, so that is why if block is getting printed. Now let's do an example of when statement. Let's create a new file. Go to new, this Kotlin file. Now let's name it example 3. Alright, so this is example 3. Now let's start with the when example. Function main. Inside this we'll create a variable named coupon. So let's say the variable is var coupon, and let's assign it a value 5. Alright, now the when statement works as switch statements. It is used to select one code block or one code branch out of many code blocks or code branches based on the conditional expression. Whichsoever code branch matches with the condition, that particular code branch will execute. Alright, so let's start with it. We'll use when keyword, and let's say coupon is the name of the variable, and the value of coupon is 5, as we can see, as we have already declared that. Now inside when, the first branch would be, so this is how you can create a first branch, and if there are multiple lines, then you have to use the brackets. Alright, so here we will print here is your coffee. Alright, so first message is this. The second message would be like forgot to enter tea. Yeah. So the second message, let's say here is your tea, we will write so here is your tea. So in the third branch we'll write here is your green tea. The fourth branch will write here is your juice. And in the fifth line or the fifth branch we will write here is your water. So this is how we can create this. We can also create a default value. For that we have to use the else statement. We'll write else. Write invalid input. Alright, so this is how we are doing it. And so the value of coupon is 5, and whichsoever values among these, like 1, 2, 3, 4, 5, 5 obviously will match it. That particular statement or line will be printed. So let's save this one. And let's try to run it. So there's an error, as you can see. So for that we have to use the arrow operator instead of these brackets. So let's do that. So now if any value other than these 5 values is there in this variable, then this default message will be printed, that is invalid input. So now let's save it again and now run it. As you can see, here is your water, as the value was 5. Let's say the value is 6. It must show the invalid input, as there are only 5 values. So now let's try to run this and let's check if it is working fine or not. As you can see, invalid input, as we have entered 6 over here, which is not in this 1, 2, 3, 4, 5. So that is why it is printing invalid input. So now let's do an example of array. Let's create a new file, Kotlin file. Now let's name it example4. Alright, now the main function. Right, now inside this function, first of all we will create an array. So how we will do that? Well, let's say the name of the function is arr1 equals array of, as we have discussed already, array of now the number of elements like 2, 4, 6, 8, 12. So these are the elements of array 1. Now similarly we will create an array 2. Right, array array of now the elements 1, 3, 5, 7, 9, 11. Alright, now here we will use a set function. So if we want to set a particular element at a particular position, then we'll use set, and if we want to display a particular element of the array, then we'll use get. So first of all, we'll understand set. So array1 dot set. So first here we will write the position. Let's say 1 is the position, and at 1 position we want to set 5 as an element. So this is the syntax for it. And let's say for array2 dot set. Now here we want to set at 0th position, and we want to set 2 element. So first is the position and second is the element that we want to set at that position. Alright, now we'll see the get function. So get is used to display the particular element of an array. So let's say array1 dot get. Let's say I want to print the 5th element, that is 14th in array1 case. So I'll do this. Similarly for array2, and in array2 case I want to print this 4th element, that is 9. Now after that we'll use println so that the result come out vertically. Alright, now if we want to print each and every element of an array, so this is how we can do it. For element in arr1, here element is the variable, array1 is the name of the array, and one by one it will print all the elements. So here we will write element. Yeah, it's done. Let's save it now. And now let's run it. As we can see, 14 and 9. So as we know, here we have set 5 at 1th position, at first position. So 0, 1. So at place of 4 there is 5 now. And here at 0th position, that is at 1 position, there is 2. So first of all, here we have printed this get 5. So at array 1 position, at 5th position, 0, 1, 2, 3, 4, 5, there is 14. So that is why it is printing 14. In array 2 at 4th position there is 9. So here it is printing 9. After that, here we are printing all the elements of the array. So as we can see, at the first position we have set 5 instead of 4. Here we are doing that. So that is why here we can see 2, 5, not 4, then 6, 8, 12, 14. Similarly, as you can see, at 0th position in array 2, that is here, we have set 2. So we can see instead of 1 there is 2, 3, 5, 7, 9 and then 11. So this is how we can set some elements at a particular position and print those elements and print the array as well. So now let's do another example. Right, so we'll write function main. Now inside this we will create an array, val arr1. Now in Kotlin you can create an array having the integer elements and character elements or string elements as well in a same array. So I'll show you that. Array of, so first we'll write down the integer elements, let's say 2, 4, 6, and then there are string elements, let's say 8 and then 10. So this is our array. Within the same array there are integer elements and string elements. Alright, now using for loop we'll try to print this element in array1 dot. Here dot indices means if we want to print the index of each of these elements. Let's say if we just want to print the elements, so we'll not use this, we'll simply print ln, and then we'll do is array1. This is just for printing purpose. Element, then alright, so now let's save it. Let's run it. As you can see, 2, 4, 6, 8, 10. It is printing without any error. So we can easily do that in Kotlin. And these are the indexes. For the index, if we want to print the index of these elements, we'll do is dot indices. Now let's save it again and run it. As you can see, array of 1 with 0 index, 0, 1, 2, 3, 4. The index is correct, but the elements are not. So I think this, yeah, we forgot to write array of, then the bracket. Now let's save it again. Now let's again try to run this. Array of 1, yeah. Now again let's try to run this. Alright, as you can see, array with index numbers will print 2, 4, 6, 8, 10. So not only the integer elements are getting printed, but also the string elements are also getting printed along with the index number. Because of this dot indices, we are also able to print the index of array elements. So these were some examples of Kotlin language. You can try some more examples on it. The more you'll practice, the more you'll get to know about this language. Conditionals in Kotlin. Conditional expression refers to a situation that may happen or exist if a specific condition is met. For example, there's a statement like, we can sit on the front benches if we reached before the given time. Now here the conditional statement is, if we reached before the given time, and the main clause is, we can sit on the front benches. So here, sitting on the front bench, which is a main clause, is dependent on if they reach before the time. So now, there are some conditionals in Kotlin, like if, else, and else if. So let's have a look at that. First is if statement. If is used when a block of code must be executed based on the condition to be true.
Second is else statement. Else is used when a block of code must be executed if the same condition is false. Third is else if statement. Else if is used to specify a new condition if the previous condition is false. We will understand them in detail. Now, moving on to different types of if-else expressions. First is if expression, second is if-else expression, third is if-else-if ladder expression, and fourth is nested if expression. Now, let's understand the if expression first. If expression is a conditional statement which checks if a particular condition is satisfied. The condition is specified inside the if brackets and it checks if it met the condition or not. If they met the condition, then the block will execute, otherwise not. As we can see, there's a statement, then there is if condition. If the condition is satisfied, that is, if it is true, then only the if code will execute, otherwise, if it is false, then control will exit. Now, moving on to if-else expression. The if-else expression has two blocks of statements. The if block executes if the condition is true, and if the condition is false, then the else block executes. The if-else is similar to if expression. The only difference is it has one extra block known as else block. A simple example of if-else is a conversation between a father and a son. The father says, if you scored more than 85%, then I will buy you a car. But if you scored between 75 to 85%, then I will buy you a bike. Here, I will buy you a car is the code written inside the if block, and I will buy you a bike is a code written inside the else block. So when the son scores 85%, then his father buy him a car. But if he scores between 75 to 85% range, then he will get the bike. Now, moving on to if-else-if ladder expression. Kotlin if-else-if condition is used when there are multiple conditions to be checked. In this expression, first the if expression is checked. If it's true, then it executes the if block, otherwise it moves to the other else if conditions. If none of the condition turns out to be true, then it executes the last final else expression. To understand it, let's have a look at this example. According to this example, if a student scores marks between 80 and 105, then the cutoff is not cleared, but he or she can sit for the second examination. If the mark scored is between 105 and 130, then the cutoff is cleared. If the marks scored between 130 and 180, then the cutoff is cleared and also there will be no fee. And else, cutoff not cleared. So by this example, we understood that there are multiple conditions and each condition has a specific criteria. If the marks of the student is fit in that criteria, then that specific block gets executed. Now, moving on to the nested if expression. In Kotlin nested if expression, there are if statements inside another if statement. First, the if statement is checked. If it is true, then the nested if condition is checked. If the conditions turns out to be false, then it will move to the else expression. In this example, it checks for true in condition 1, then checks for true in condition 2. If condition 2 evaluates to true, statement 1, that is even number, is executed. Otherwise, statement 2, that is odd number, is executed. Similarly, if condition 1 evaluates to false, then else block executes and the statement's negative number is printed. So, as we have understood all of these expressions,
So now let's do its practical implementation. So this is our code editor, that is IntelliJ IDEA. So here we will be doing some examples of Kotlin if else. So let's start with the first example of if else expression. So we'll write function main, and inside this function we'll create marks. Let's say the marks of the test. So we have named it test marks. Now let's say he scored 78, he or she scored 78. Now we'll use if condition, and we'll write the condition that if text marks is, let's say, less than 75, then we will print you didn't qualify the test. So we'll write ln didn't qualified the test. So basically, to qualify a test you have to score more than 75. So in else block we'll write print ln, we'll write you qualified the test. So basically, if you have scored less than 75 marks, you are not qualified, but if you have scored more than 75, then you have qualified the test. Here we have used the basic if else expression. Here the test marks is the variable that we have set, let's say 78, and if we have changed it like less than 75, let's say 70, then it will get printed you didn't qualify the test. But as we have set the value of test marks as 78, so it means you qualified the test will print. It's a simple example. Let's try to run this. So as you can see, you qualified the test is printed. So as we know that the marks is 78, so it is printing you qualified the test. And if we have, let's say, marks is 70, now again let's try to print it. Now it will print you didn't qualify the test. As you can see, it is printing you didn't qualify the test. So now let's have a look at an example of nested if. So now create a new file. Here we have to change the name of this file. Alright, so in this example, again we'll write function main. Inside this function we'll create a variable. Let's say the name of the variable is num, and we'll assign it 50. Now we'll set a condition. If the value of num is, let's say, less than 100, then we'll print number is less than 100. First of all, we'll print that. Now if num is equal to 50, so this is the if condition inside the first if condition. This is the first if condition, this is the if condition inside this if condition. So it's a nested if. Now here we'll print that number equal to 50.
Now inside this if condition, again we'll write an if condition saying that if number is, let's say, greater than 40, then we'll print number is greater than 40. Basically we are printing the condition. Alright, so this is the code. Now first if condition, then there is nested if condition, then there is another nested if condition. First condition says if the number is less than 100, then it will print number is less than 100. If it is equal to 50, then it will print number equal to 50. If it is greater than 40, then it will print the number is greater than 40. So now let's try to run this program. So as we can see, number is less than 100. First it is printing. After that number equal to 50. Then the number is greater than 40. So as we know the number is 50, that is why all the three statements are printed. Now let's say if we change this number, like let's say the number is 45. If the number is 45, then number is less than 100 is printed, and this sentence, that is the number is greater than 100 is printed, and not number equal to 50, because to print this number equal to 50 sentence, the number must be equal to 50. Now let's try to run this again. So as you can see, number is less than 100 is only getting printed, because as we can see here, to get inside this if condition, the number must be 50. As the number is not 50 but 45, so it is not getting inside this if condition. So that is why this condition is also not getting checked. So that is why only number is less than 100 is getting printed. So this is an example of nested if expression. Now let's do an example of if Lzf Ladder expression. Let's name it if else 3. Alright, so now here we will do an example of if else if ladder expression, where we will give grades to the student based on their marks. So let's start function main. Inside this we'll create a variable, let's say val score, and assign it a value. So this value is the marks of the score, or you can say the score is 76. Now we'll create a variable whose type is string. Now after that we'll have to assign this grade. So basically we are assigning the value of if else if ladder expression to this variable grade. So this is how we do it. If score variable is greater than equal to 90, that is if the score is greater than 90, then we'll simply print your grade is A+. So yeah, here we'll do it. Grade is A+. Now if a student scores more than 90, then his grade is A+. Now here we'll write else if. So inside the else if there is a condition. We can write the condition inside the else if. As we know, score is greater than equal to, let's say, 80, then we'll print your grade is A+. Your grade is A, not A+. Now after that, another else if the score is greater than equal to 70, then the grade is, we'll write your grade is B+. Else if the score is greater than 60, similarly write your grade is B. We can do same for all of these. We can just copy paste it. So this one is 60, then let's make here 50 and the grade would be C. C+. Now here would be, let's say 40. We'll do it 40 and the grade would be C. Now after that 35. Let's make it 35. Your grade is D. Now in else block we'll simply write that is your grade is F. That is if you scored below 35, your grade is F, that is your fail. So you must score more than 35 to pass the exam. Alright, now after that we can print this grade variable. And let's try to run this. So as you can see, your grade is B+. It's getting printed, and I think by mistake there is N in between. Here it is. That is why it is printing N here. So our score was 76, so that is why it is getting printed your grade is B+. So this expression is used when there is a need of multiple conditions. Like in this case, we had the need of multiple expressions, like one condition is score must be greater than 90, then only the score will be A+, then score must be greater than 70, score must be greater than 60. Similarly, for every statement that is to be printed, there must be a specific condition. And in this type of case, we use if-else-if ladder expression. So these were few examples of if-else expressions.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Are used to repeatedly execute a series of statements until a certain condition is met. Typically, a process is carried out such as retrieving and altering data, and then a condition is verified, such as whether a counter has reached a specified value. If it hasn't, the next instruction in the sequence is a command to go back to the first instruction in the sequence and repeat it. So, until a specified or given condition is true, or the loop is broken with the break statement, a series of statements are going to execute. There are various types of loops in Kotlin, like for loops, for each loop, for loop with ranges, while loop, and do while loop. So let's go ahead and understand these loops. Now we'll start with for loop in Kotlin. A for loop is a conditional iterative statement that checks for a specific condition and then constantly executes a block of code as long as those criteria are met. The for loop differs from other looping statements in that it provides an explicit loop counter that allows the loop's body to know the exact sequence of each iteration. The for loop is used in Kotlin to traverse over ranges, arrays and maps. As we can see in the diagram, first there is an initial statement, then there is a condition, and if that condition evaluates to be true, then the statement inside the loop body are executed and updated. The updation can be incremental or decremental. Then again, the condition is checked. If it's true, then the same process will get repeated, and if the condition is not satisfied, then the control jumps out of the loop. This complete process will keep on repeating until the condition evaluates to be false. Now, let's understand for loop with the help of an example. So this is our code editor IntelliJ IDEA. Here we will be doing an example of for loop in which we will print the odd and even elements from an array. So here we will use a for loop and if else condition. So let's start. First of all, we'll make the main function main. Inside this function, let's declare an array. Val num is the name of the array, and the array of function. Inside this, we'll mention the elements of the array. Let's say 7, 21, then let's say 23. So these are the elements of the array. Now after this, we will simply print a message. Let's say like the odd and even numbers in the list are as follows, and then we will apply the logic. Right? The odd even numbers are as follows. Right? Now we'll use for loop. Now inside this for loop, item will be the name of the variable that will store the variables or elements of the num array one by one. So num is the name of the array, and in between there will be in operator. So one by one, each element of the array will be stored in item, and now we'll use if condition. Now we have to print even and odd numbers. The logic is simple. We'll write if item $sign divided by 2, if the remainder is equals to 0, then it means it is an even number. So any even number on when it is divided by 2, it will give 0 as a remainder. So if it will give 0 as the remainder, then we will print even number then here we'll write item. That particular element will be printed. Alright, now in else block we'll do println, and here we will write odd number. Here again we'll write plus item. So alright, I think our code is done and we can run it. Let's try to run this one. So as we can see, even numbers and odd numbers are getting printed. So 16 is an even number, 2 is an even number, odd numbers 11, 17, 28 even number, odd number 39, and even number 10. So I think all the elements are getting covered. Here we go, 7, 21, odd number. So yeah, so this is how you can use for loop, and here we also have used if and else statements. Now let's understand for each loop. The for each method in Kotlin allows you to access elements in a collection or list and perform actions on them. We can achieve the same thing using the for loop, but several for loops would quickly make your code unreadable. As we can see in this example, there is a list named mylist, and like in arrays we use array of function. Similarly, in list we use list of function. The elements of the list are in winter, is, and coming. So there are three elements. First is winter, then is, then coming. So to print each element of the list, we will use for each loop. As we can see, here we have used mylist.forEach, that is the for each loop, and then we will print the iterator to print all the elements of the array. Now let's do an example on for each loop to understand it better. So again we are back in our code editor. Here we will be doing an example of for each loop. So this example would be a simple example, function main, and inside this function we will create a list. Let's say where a list, let's name it a list. Okay, so after that we'll use list of function, and also let's mention the data type. Alright, so now inside this list we will mention the elements. Let's say 110 and 265 and let's say 315. So these are random elements. Alright, now we will have to create a variable sum and initialize it with 0. Now using this list a list, that is the name of the list, we will use a for each loop to iterate through each element of the list. We'll use for each, E must be capital. After that, right, for each, and now we will use this sum variable to do a simple sum of each element of the list. Sum plus here it. So it will be storing each element one by one. It will sum, with the help of sum, it will add each element to one another. So initially sum is 0. When 110 is added, then 265 is added to 110, then 315 to added to both of them. So alright, now all we need to do is to print this. We'll write println sum. So here we go. Now I think we can try to run this one, although it is showing an error, but let's try to run this. So as I thought, I think we have to write the correct way only. So this is the right syntax of for each loop, and yeah, so now let's try to run it. So as you can see, 690 is getting printed. So we have to use for each bracket with for each only, and we can't enter or put space with it. So yeah, so this is the syntax of it. Now let's move on to the next loop, which is for loop with ranges. A range is a set of values that fall within a specified lower and upper limit, and the values can be numbers, characters, or objects. Ranges might be incremental or decremental, but the difference between two values is always 1. As we can see in the example, inside the for loop num in 1 to 8, here dot dot is the operator. It means all the numbers from 1 to 8 range will be printed. Also, we can use a step function to print the elements with a gap. And we also have to mention the gap, like step 2. There are more library functions that build ranges that aren't covered by the double dot operator. For example, down2 creates a range that counts down, while range2 creates a range that advances to a certain value. Now, as we have understood ranges, now let's understand while loop. While loops are used to repeatedly cycle a block of code as long as the specified condition returns true. The condition is verified first, and if it is true, the block's code is run. Every time it enters the block, the condition is checked, and as a result, the code will keep running until the condition is met. Once the loop starts, the condition is checked. If that condition is satisfied, then the set of instructions are executed, and if the conditions are not satisfied, then the control jumps out of the loop. This complete process will keep on repeating and executing unless the condition evaluates to be false. Now let's understand while loop with the help of an example. So now here we will be doing an example of while loop. So here we will use an array and we will create elements of the array like positive and negative. Then using the while loop, we will print the positive numbers and the negative numbers separately. So let's start. First of all, we'll create the main function, and inside this main function we'll create an array. Let's say ARR is the name of the array, and here we are using the array of function. Inside this function we'll write down the elements like 52, any random elements, minus 77, we have to write some negative elements as well, minus 67 let's say, and minus 20. Alright, after that we'll create a variable, let's say I, and assign it 0, initialize it with 0. So here we are initializing it. Now within the while loop we will write I less than ARR dot size, that the array size. So it means this loop will keep on iterating till the size of the array is greater than 0, and when it becomes 0 the loop will break or the control jumps out of the loop. Alright, so as we know I is 0, so that is why I less than array dot size we have used. Now in if condition we'll write ARR of I greater than 0, that is positive number. If the element here, if the element is positive, that is greater than 0, then we'll print positive number. Right, now ARR I, so that is how we will print it. Now here we'll write else block, and inside the else block again we will print negative number ARR of I. Okay, so after that we have to increment I++. Basically we have to make the loop to keep on iterating, so that is why we have used I++ for the updation, like to move to the next element. In for loop we don't do the updation part like ourselves, but in while loop we have to do that. Now let's try to run this. So here we go, 52, 10 positive numbers, minus 77 negative, 82 is positive, then there are negative numbers. So here we have used the while loop, and it is easy, pretty much easy. Now let's move to the next loop, which is a do while loop. The do while loop. The while loop and do while loop are quite the same kind of loops. The only difference is that the function is run at least once before the condition is evaluated in the do while loop. The while loop, on the other hand, checks the condition before executing the function. So as we can see in the diagram, the do while loop starts and the set of instructions are executed. After that, the while loop condition is checked. If it is true, then again the set of instructions or statement will execute. So basically in do while loop, the set of instruction will execute once before checking the condition, and after that it will check for the condition to be true. So we can say the set of instructions will execute once even if the condition is not met. So let's understand do while loop with the help of an example. here we will do an example of Fibonacci series. So Fibonacci series is the series in which the sum of the previous two elements is equal to the third element. So let's start. First of all, we'll write function main. Now inside this we will create a variable, let's I, this is a counter variable, so we'll start with 1, and now another variable, let's say n, let's assign it 10. After that we'll create a sum variable and assign it 0, then where, let's say f1 and make it 0, and where f2 and we'll make it 1. Alright, so we know in Fibonacci sequence first two elements are 0 and 1. Alright, so that is why we have assigned f2 as 1 and we'll print it. Now we have to do this example with the help of do while loop. So first of all we'll write do, and inside this do we'll write I++, that is we are incrementing the counter. Then we'll print f1 because in Fibonacci series the first number is always 0. So we'll write f1. We have assigned f1 as 0, so it will get printed. Now we'll write sum equals f1 plus f2. This is the logic, and after this we'll write f1 equals to f2, that is we are assigning the value of f2 to f1, and f2 equals sum. So here what we are doing is, for each iteration we are assigning second number to the first number and assigning the sum of the last two numbers to the second number. So Fibonacci sequence works that way: 0, 1, 1, that is the sum of the previous two elements, is the third element. Like 0 plus 1 equals to 1, then 1 plus 1 equals to 2, then 2 plus 1 equals to 3. So that is how it goes on. Now after do block we'll use while loop. Inside the while loop we'll put a condition that if I is less than equal to n. As we know the value of I is 1, on increment it becomes 2, and the value of n is 10. So this block will keep on iterating till I becomes equal to 10. And as we know that I is now 2 after this block executes, which is less than 10, so again this block will execute. So it keeps on iterating till I becomes equal to 10. So it will print up to 10, that is 0 to 10 digits of Fibonacci series. Now let's try to run this one. As we can see, these are the Fibonacci series: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. There are total 10 digits. So as we can see, 0 plus 1 equals to 1, 1 plus 2 equals to 3, then there is 3 plus 5 equals to 8, then there is 8 plus 13 equals to 21, 13 plus 21 equals to 34. So this is our Fibonacci series, and we have done it with the help of do while loop. So these were some examples of loops in Kotlin. You can try some more examples on it. It will help you understand this topic better. Kotlin functions. Functions in Kotlin is very much similar to functions in Java. There are some minor differences in between them. So let's have a look at them. A Kotlin function can be defined as a block of code which is used to hold the data. This block of code has a name and is defined with fun keyword. For example, as we can see, fun is the keyword here and info here is the name of the function. A Kotlin function divides the program into small modules. These functions can easily be invoked by making a call. And to make a call, we use the name of the function with parentheses. As we can see in the example, the function info is getting invoked from the main function. That is, from the main function we are making a call to the info function by using the name of the function with parentheses. Now let's understand function parameters. Parameters can be defined as the information that are passed to the function. So basically, functions can accept the data or information passed to them. These informations and data are passed in the form of parameters. After receiving the data or information, function can easily use this data to calculate or display as per the function definition. The parameters are specified after the name of the function and is mentioned inside parentheses separated by commas. And we can easily pass as much parameters as we want. For example, as you can see, function calc is accepting 3 parameters a, b and c of integer type. These 3 arguments or values are passed from the main function where the function call is made. So a, b and c 3 arguments are passed to the calc function and the function is providing the average of these 3 values. Also, the values that are passed to the functions are called arguments and the parameters are the values that are defined in the function definition. So now let's understand the next topic, which is function returning values. Just like printing the values, functions can also return values. To return a value or values, a return keyword is used. Also, while returning a value, the return type of the function is also specified. As you can see in the example, int is the return type of the function and return keyword is used to return values to the main function where they are getting printed. So now moving on to the functions with no return types. Kotlin function with no return type. In Kotlin language, if the function is not returning anything, then we don't need to specify any return type. But if we want to mention the return type, then we can add unit as the return type. So basically, unit type in Kotlin is like void type in Java. That means it is used with function that doesn't return anything. Next is higher order functions. The higher order function in Kotlin is a function that can accept the functions as a parameter and can also return a function. We have heard that function accept variables, but we haven't heard about function accepting other functions. In higher order function, we can easily do that. So, as we can see in the example of higher order function, the name of the function is high order and is accepting 2 integer values, that is num1 and num2, and a function whose name is fname. Now this function fname is accepting 2 integer values and its return type is int. Inside the function body, we are calling fname function and printing it. Let's understand it with the help of an example. So this is our Kotlin playground. Here we'll do an example of higher order function. We'll do a basic example of higher order function. So let's start. First of all, we'll create the main function, function main. And inside this main function, let's name the higher order function as high order. You can name it as per your choice. I have named it high order. And now let's pass the variables. Let's say 50, 80, and let's say 40. Now we have to pass the function to this higher order function. So we can do that with the help of these 2 colon operators and then the name of the function. Let's say the name of the function is my function. So here we are passing 3 variables and a function to the higher order function. Now we'll create the higher order function. We'll write fun keyword, then high order, and now inside the parentheses we'll write num1, int the parameters, that is 50, 80, 40. We have to write the parameters. Similarly, num3. Now after that, here we are accepting a function as well. So we'll write the name. Let's say name of the function is funcName, and here int and int the type of the values that this function will be accepting. Here also we have to mention the types of the function that this function will be accepting and the return type of the function as well. So int is the return type of this function. We'll have to mention that as well. And by mistake we have done this. We have to use arrow operator for that. And yeah. Now we'll write the print. Basically we'll call the function in which we will define the definition of this function. So let's say the function name was funcName, and these three are the parameters, num1, num2 and num3. We are passing these arguments. Now let's create this function definition. So we'll create fun keyword my function is accepting num1 of integer type, num2 of integer type, and num3 of integer type. Now after that, the return type of the function is int. Alright. Now let's say we want to do the average of these three numbers. So what we'll do is we'll write return num1 plus num2 plus num3 divided by 3. Alright, so all we need to do is just enclose it within the brackets. Yeah, now let's try to run this. As you can see, 50 plus 40, 90. 90 and 80 is equals to 170. 170 on divided by, when it is divided by 3, it will give you 56.3 something. And as we have used integer value, so it is showing 56 only. So what we are doing here is, first of all, we are calling the high order function. So basically this is a higher order function and we have named it high order, and we are passing 3 integer values and 1 function. So these 3 integer values are passing over here, these are the parameters, and this is how we accept function as a parameter. This is the syntax of it. After that, we are here calling the definition of this function. So this is the definition, we are calling this function, and this is the definition of this function. The value is calculated over here and then is returned here, and then here it is getting printed. So the answer or the output of this program is 56, as we can see. So this is a higher order function. Now let's understand Lambda function. Lambda function. Lambda is an abbreviated form of function writing. The Lambda function is written without a name and is enclosed in curly brackets. The Lambda function has the basic syntax. Arguments or variables are mentioned on the left hand side of the arrow operator, and the body of the function is present on the right hand side of the arrow operator. In the example, avg is the Lambda variable, n1, n2 and n3 on the left side of the arrow operator are the parameters, and on the right side is the function body, that is the average of 3 parameters. So as we have understood the Lambda functions and the higher order function as well, now let's understand how to use higher order function with Lambda function. So Lambda function allows us to eliminate the code and write the code more compactly. As we can see in this example, we have used the lambda function instead of the normal function, which has decreased the lines of code. Now, let's understand this with the help of an example. So, this is our example of higher order function that we have done previously. Now, we will do this example or edit this example with lambda function. So now we'll understand how to use higher order function and lambda function together, and it will make our code shorter and more compact. So as we can see, here we have used two colon operators with the name of the function. Now all we need to do is to create a lambda function over here. And for that, as we know that there is no name for a lambda function, the lambda function is enclosed in two brackets. Now let's say num1 int. This is the parameters or the variables that is on the left hand side of the arrow operator. Then num2, num3, after that, here we can see, here we have used the arrow operator. Now we have moved to the right hand side of the arrow operator, which is the function body. Now we'll use the parenthesis num1 plus num2 plus num3. So basically this is the function body or the function definition, we can say. So now here we are doing the average of these three numbers as we have done previously in the higher order function. Now here we don't have to use this function, we can just eliminate this one. Now as we can see, our function is almost done, and let's try to run this program. As we can see, the output is 56. So here we have used the lambda function. So this part, which is the left hand side part of the arrow operator, this is the variables or the values, and this part on the right hand side is the function body. So the lambda function is enclosed in two brackets, as we can see. Here we have passed the three variables, and this is the lambda function. Also, we have eliminated the my function because in that particular function we are just defining or doing the calculation, and that we have already done in this part. So we no longer need that function. So as we can see, here we are using higher order function with lambda function. So first is, what is Kotlin multi-platform? The Kotlin multi-platform is a feature released in 2017 with Kotlin 1.2 version. This feature allows us to write the same code on multiple platforms directly. It focuses on cross-platform app development. It is based on the idea of write once, run anywhere approach. But it takes the concept of write once, run anywhere to a much higher level, in which we can write the code once and target multiple platforms. The Kotlin multi-platform allows you to include other platforms like Linux, Windows, and the web, while its subset, that is Kotlin multi-platform mobile, allows the developer to write business logic code for iOS and Android from a single code base. Now, as we have understood what is Kotlin multi-platform, now let's understand how Kotlin multi-platform works. So let's take Android and iOS. The shared business logic code for Android gets converted to Java bytecode that can be executed in JVM. And Android has the virtual machine, so it can easily run it. But in case of iOS, there is no virtual machine. So the code is converted to the native code that can be executed on iOS. Now in Kotlin compiler, there is a front end which converts the code into intermediate representation known as IR. And the backend converts that intermediate representation to machine executable code. So in case of Android, it converts it into Java bytecode, and for iOS, it converts it into iOS native machine code. So as we have understood how Kotlin multi-platform works, now let's understand common Kotlin code. To make common Kotlin code run, Kotlin provides platform-specific compilers. To convert the code according to different platforms, it provides different compilers. These platform-specific versions include Kotlin/JVM, Kotlin/JavaScript, and Kotlin/native. These versions contain the platform-specific tools and libraries and also the extension to Kotlin language. Each platform-specific version includes various platforms. For example, JVM includes Java 8, Java 6, and Android. Then the JavaScript includes browser and Node. The native includes iOS, Mac, Windows, Linux, etc. Multi-platform libraries helps in developing shared parts of the project at one area by providing APIs for common Kotlin code and later share it with all of the target platforms. The versions of platform-specific libraries provide the libraries that can be used to increase the platform-specific capabilities of the platforms that are targeted. Now, let's understand the benefits of Kotlin multiprogramming. So let's start with the first one, which is quick and clean code. In Kotlin multi-platform, we don't have to recreate and rewrite the code for different platforms. We can simply share the common code between platforms, which saves a huge amount of time. Features like interoperability makes things very easy and quick as well. Also, there is no lagging behind the native platforms, and because of that, the developers don't have to wait until the new features are added for the support. Next is fast development. So as we have already discussed that code sharing saves a lot of time and helps in making the development process much faster and easier. Its features including null safety, IDE support, and interoperability with Java makes it less complex and fast. Next is one language for cross-platform and native apps. Most cross-platform app development tools don't allow you to use the capabilities of native to iOS and Android devices. In Kotlin, we don't need to introduce any new programming language to the codebase. It is easy to make our Android app work on iOS devices without changing much in code. The major advantage of using Kotlin multi-platform is that we can write the code once and use it on both mobile platforms that are Android and iOS. Next is support and community. Kotlin is pretty famous in many companies and organizations. Also, after Google's statement of Kotlin as an official language for Android, many companies are opting this language and a huge amount of users started working on this language, which means there is a huge community support for the Kotlin language. The developers who are already familiar with Java can easily switch to Kotlin as it is fully interoperable with it and easy to learn. So the Java community also adds up to the Kotlin's community. Now let's have a look at some applications that are built using Kotlin multi-platform. This includes Netflix, Autodesk, VMware, Trello, Philips, IceRock. So let's start with Netflix. Netflix, the popular OTT platform, has rebuilt the current user interface player in the Netflix Android application using Kotlin. Next is Autodesk. Autodesk is a multinational software corporation. Kotlin works well with iOS and Android without any Java native interface, which is a major reason for the company to opt Kotlin multi-platform. Next is VMware. VMware is an American cloud computing and virtualization technology company. The VMware development team wanted a cross-platform strategy for mobile applications. Then the Kotlin multi-platform was selected. And now it is the default go-to framework of choice for VMware. Next is Trello. Trello is a project management application. The Android application of Trello is built using Kotlin. Trello uses Kotlin because of its interoperability with Java. Next is Philips. Philips is a popular multinational corporation and we all have heard about this company. In Philips, Kotlin multi-platform proved to be a faster at implementing the new features and also to get more interaction in the team between Android and iOS developers. The last one is IceRock. IceRock is an outsourced company that provides mobile and backend solutions for various industries and market segments. It uses Kotlin multi-platform mobile to create applications for its clients. Apart from these, there are some more applications and companies that have opted the Kotlin multi-platform.
What are threads? To understand coroutines in detail, first we will have to understand the threads. So let's understand it a little. So the programs are just a set of instructions. When a program runs, a process is created, which contains memory, process ID, etc. In that process, there are threads that are used to execute information. Every process has at least one thread or more than one thread. Threads help with the high performance applications and they work in a sequential order, one after the other. Whenever a thread gets stuck while running an instruction, then the other thread executes the rest of the instructions. So these were threads. Now, as we have understood about threads, so let's learn about coroutines. Coroutines stands for cooperating functions. The word co stands for cooperation and routine stands for functions. The coroutines can not only do all the things that a thread can, but is also very efficient. Coroutines are lightweight threads that help to write simplified asynchronous code that keeps the application responsive while maintaining heavy tasks like network calls. Coroutines are executed inside the thread and are also suspendable. Here, the word suspendable means we can execute some instructions and then stop the coroutine in between the execution and continue when we wish to. And they can also switch between the threads, which gives coroutines an edge over threads. So as we have understood about coroutines, so now let's learn about some features of coroutine. So these are the features of Kotlin coroutines. First one is coroutines are lightweight. Due to the support for the suspension, we can run many coroutines on a single thread, which doesn't block the thread where the coroutine is running. Coroutine has a collection of threads that can be used when required. When the task is done, the thread is kept back to the collection and reused when need. So this was the first feature. Now moving on to the second feature, which is less memory leaks. There are very less memory leaks in Kotlin because of the structured concurrency. The Kotlin coroutines follow the structured concurrency. This structured concurrency means the new coroutine can only be launched in a particular coroutine scope, which sets the lifetime of the coroutine. During the implementation, a large number of coroutines are launched and the structured concurrency take care of those so that they are not lost or leaked. This was the second feature. Next is built-in cancellation support. Cancellation in coroutine is interactive. In order to be cancelable, a coroutine must be cooperative. But if it is not cooperative, then it will wait for the coroutine to finish. There are two ways to make a coroutine cancelable. One, through using suspending functions through Kotlin.coroutines like delay function, yield function, etc. These were cancelable. And second, using coroutine scope.isActive boolean flag. There can be many reasons to cancel a coroutine, and also a coroutine cannot be cancelled if it is working in computation. Now, moving on to the last feature, that is Jetpack integration. There are many libraries of Jetpack that provide support for coroutines. For example, Android KTX is a set of Kotlin extensions that provide Android platform and other APIs, etc. The Jetpack is basically a collection of Android development components that helps in building Android apps and making complex things simple and easy. These were some features of coroutine. Now, let's understand an example of coroutine. But before that, we have to understand some terms of coroutines, which are launch, delay, and run blocking. First is launch. Now, launch is a coroutine builder. It launches a new coroutine concurrently, that is, without blocking the current thread. It is automatically cancelled when the resulting job is cancelled, and it doesn't return any result. Now next is delay. Delay is a suspending function, which is used to suspend a function for a particular time and resumes it after that time. It doesn't really block the underlying thread, but allows the other coroutines to run and use the underlying thread. Also, it is a cancelable function. Then there is run blocking. Run blocking is a coroutine builder again. It basically runs a new coroutine and blocks the current thread until its completion. Or, in other words, the thread that runs in it gets blocked for the given duration until all the code blocks inside the brackets of run block complete their execution. Now, as you can see in this example, here the run blocking refers to the thread that runs it, that is the main thread. It is the scope of the coroutine. Launch. Here launch will launch a new coroutine concurrently. Then there is delay. Delay will suspend the coroutine for a selected time. Here that selected time is 2 seconds. By default the time is in milliseconds. Now here the word Sam will be printed after my name is because of the time delay for 2 seconds. On printing it, it will display my name is Sam. Let's take this example on Kotlin Playground. Here it is. Here we have written that example. Here we can see there is a delay of 2000 L, that is 2000 millisecond, which is equal to 2 seconds. So that is why my name is printed earlier than Sam is getting printed. Let's run it and let's check the output. As you can see, my name is Sam is getting printed because we have delayed this Sam for like 2 seconds. And now we'll use delay here. Delay, let's say 3 seconds, 3000 milliseconds, which is equal to 3 seconds. So as you can see, there's a delay of 2 seconds. Here is the delay of 3 seconds. Now what will happen is Sam will print first. After that my name is printed. As you can see, Sam my name is. So I want to show you that how this delay function work. Because here the delay is now 3 seconds, which is greater than 2 seconds. That is why my name is getting printed later. Now moving on to the next topic, which is basics of coroutine. So first is scope builder. The coroutine scope is used to declare your own scope. Unlike run blocking, it just suspends and releases the threads underlying. It is used to set the scope for new coroutines. coroutine scope is responsible for controlling the life cycle of a group of coroutines and their context. Scopes wait for their associated coroutines to complete before completing themselves. The coroutine builder is an extension of coroutine scope. Now next is explicit job. A job object is returned by launch coroutine builder, whose task is to explicitly wait for the child coroutine completion. Jobs acts as a handle to the coroutine in the queue. For every coroutine that is created, it returns a job instance which identifies the coroutine uniquely and manages its lifecycle. Then there is suspending functions. Suspending functions are those functions that can be paused and then continued later. They can be used inside the coroutines and can use other suspending functions as well. They are used for long-running operations and wait for it to complete without blocking. The syntax of suspending functions is same as that of the normal function, but with the addition of suspended keyword. So these were some basics of coroutine. So what is Kotlin Jetpack Compose? The Jetpack Compose is a modern user interface development toolkit. It makes the app development process easy and speeds it up. Because of the Jetpack Compose, you can write less code as compared to the current view building approach, which also leads to less potential bugs. It's changed the way developers create user interface, making it easier and faster to write and more performant to run. Before the Jetpack Compose, XML layouts were used to make native user interface. The Jetpack Compose is much better, advanced, and easier than XML. With the help of Jetpack Compose, we can make a more declarative user interface with less code. So, as we have understood the Kotlin Jetpack Compose, so now let's have a look at why we need or use the Jetpack Compose. So why Jetpack Compose? The Jetpack Compose is used because it has huge benefits over the previous user interface building system. First, it accelerates the development. There are various features in Compose that helps in doing the task faster. For example, previews. By making multiple previews, we can save a lot of time that we earlier wasted in checking the user interface component in different states. But with the help of multiple previews, we can easily do that. Also, the Compose is compatible with existing code. Many libraries like Kotlin coroutines, view model, etc. work just fine with Compose. Second is independent. The library of Compose is not integrated with any operating system, which means it is easy to add the new features to the user interface without changing the operating system. Now next is intuitive. In Compose, the APIs that are used is intuitive and declarative. Intuitive means easy to understand and declarative means all we need to do is to describe the user interface, and the rest will be taken care of by Compose. The components that are made with the Compose are not confined to a specific activity, which makes the component easy to reuse. Fourth is powerful and feature loaded. Compose is a powerful and feature loaded that helps in making the app attractive and user-friendly. You can make the app as you desired with these animations, which are quite easy to implement. Compose has the support for dark theme, material design, animations, etc., which makes things very easy for the development. Now, how does Compose work? The word compose came from composite, which means the collection of objects. The Compose Jetpack works on a composite design pattern. This pattern is used while dealing with hierarchical data, like parent-child relationship. So in Compose, every view can contain one or more child views within it, and the child views can further have sub-child views
unlike previous approaches where we cannot introduce additional functionalities in a view. Now, as we have understood about this topic, now we will move on to the next topic, which is composable function. A composable function is just like any other normal function of Kotlin, but the only difference is it is annotated by the composable sign. It helps in transforming the data to the user interface hierarchy. All the functions with composable sign indicate that this function is the compose function, and the sign tells the compose compiler that this function is intended to convert data into user interface, and they can only be called from other composable functions. The composable function doesn't return any values like the Kotlin function, but instead emit user interface elements to the compose runtime system for rendering. As we can see in this example, composable annotation is used to make the function message a composable function. The element text is also a composable function which comes from compose library. With the preview annotation, as we can see, we are able to see how our UI, that is user interface, is going to look like. The preview are often written with composable annotation, and multiple previews can be added to the composable function having different parameters. Now, the output of this example would be hello Rahul. So now moving on to the next topic, which is layout. So layout allows us to arrange the components in such a way so that they don't overlap each other. It basically arranges the components in a proper manner, otherwise they got stacked over each other. It is one of the most important components that helps in creating user interface. It helps in alignment and arrangement purposes for the user interface. Layout is a compose function which allows us to arrange elements in a row, column, and box. So let's understand. Here we can see in this example, there is a row keyword, which means these three words, hello, there, mate, that are written inside the row function will be arranged horizontally. The row function allows us to arrange the elements in a horizontal manner. So hello, there, and mate will be arranged horizontally. Similarly, the column function lets you arrange the elements in a vertical manner. So in this case, that is in the case of column function, hello, there, mate will be arranged vertically. So this was the example of layout. Now moving on to the next topic, which is box. In box layout, the children are stacked over each other by default. So we have to align them to put them in different positions or proper positions. We use the align modifier to set the position or alignment for children elements. As we can see in this example, we have used align modifier, and we can also see there is alignment.top center and alignment.bottom center. These are the alignment options that are applied to the child user interface. There are total 9 alignment options. Let's have a look at them. First 3 are alignment.top start, alignment.top end, alignment.top center. Here, alignment.top start will align the user interface to the top left corner. Top end will align at the top right corner, and top center will align at top center position. Next 3 are alignment.center start, alignment.center end, and alignment.center. Here, center start will align the user interface to the mid left corner, center end will align at mid right corner, and center will be aligned at the mid center position in between center start and center end. Next 3 are alignment.bottom start, alignment.bottom end, and alignment.bottom center. Here, bottom start will align the user interface to the bottom left corner, bottom end will align at the bottom right corner, and bottom center will be aligned at the bottom center position, that is in between bottom start and bottom end. So these were the 9 possible alignments. Now coming to material design. As the name suggests, it helps to improve the appearance using the material design styling. There are 3 pillars of material design, which are color, typography, shape. First is color. By using values from wrapped theme, you can easily color wherever it is needed. Inside the Compose graphic package, there is a color class which is used by Jetpack Compose. To define material design, color system color class is used. There are 13 attributes that can be used, and those are primary, primary variant, secondary, secondary variant, background surface, error, on primary, on secondary, on background, on surface, on error, and is light. Each of them having different means and is used to color wherever it is needed. Then there is typography. In the material theme, there are material typography styles which are used to style or define a type system. With the help of typograph class, we can customize font style, font weight, font family, letter spacing, text decoration, and many more attributes. Third is shape. Material design allows us to define shape for small, medium, and large components as well. Just like typography, we can easily create shapes. Now, coming to next topic, which is list and animations. The list and animations are one of the most important thing for building an app. We have already discussed row and column earlier. Here, we will discuss about lazy composables. Lazy composables include lazy row and lazy column. The lazy row makes a horizontal scrolling list, and the lazy column makes the vertical scrolling list. In this example, lazy column is used. As we can see, here lazy columns is used. That is vertical scrolling list. And this is how we add elements or items. Here we are adding a single item, and here we are adding multiple items. With items, there is an integer 7, which means 7 items can be added. Now, just like list, animations are also very important for a smooth and attractive user experience. There are various APIs that can give you control and help with the animation. They are animation visibility. It is used if you are animating appearance and disappearance. Then there is animation. It is used if you want to have fine control over animation time. Then there is crossfade. It is used to switch between composables with a crossfade animation. Then there is remember infinite transition. If the animation is state-based and happens during composition and is infinite, then this is used. Next is update transition. It is used if you are animating multiple values simultaneously. So these were some APIs that can give you control over the animations. Today we will be discussing about Kotlin interview questions. The 30 questions that will be covered in this video will help you summarize every important concepts and serves as a perfect programming resource for Kotlin interviews. So now let's get started with an exciting video on Kotlin interview questions. But before we begin, make sure to subscribe to our YouTube channel and press the bell icon to never miss an update from Simplilearn. So now let's go ahead with our first question, which is name some of the features which are there in Kotlin but not in Java. So some of the features which are there in Kotlin but not in Java are null safety feature, operator overloading, coroutines, range expression, and smart casts. So these are some of the features that make Kotlin better language than Java. Now coming to the second question, which is what is the difference between where and well? Both where and val are used for declaration of variables. However, where is a general variable that can be assigned several times, whereas val is a final variable that is immutable and can only be initialized once. Now, moving on to the third question, which is, what are the advantages of when over switch in Kotlin? In Java, the word switch is used, whereas in Kotlin, the word when is used. When is more compact and effective than a regular switch, and it has superior design than switch. When can be used both an expression and a statement, but switch cannot be used as both. It can be used as statement, but it cannot be used as expression. Now, moving on to our next question, which is a multiple choice question. Which of the following are the types of constructors in Kotlin? So first is parameterized and constant constructor. Option B is primary constructor and secondary constructor. Option C is default and no argument constructor. And option D is none of the above. So you can take your time in figuring out the correct option among these four options, because I'm going to say its correct option. You can pause the video and take your time. So our correct option is option B. Primary constructor and secondary constructor are the types of constructor in Kotlin. So option B is the correct option. Now moving on to our next question, that is the fifth question, which is how to get the length of the string in Kotlin. So this is also a multiple choice question. Our options are A, str.length of, option B, length str, option C, str.length, and option D, str.length of with small o. So you can take your time in figuring out what is the correct option. Meanwhile, I'm going to say the correct option. So our right or correct option is option C, str.length. So if you want to get the length of a string in Kotlin, you can use str.length. Now, moving on to the next question, which is which feature allows removing the risk of occurrence of null pointer exception? So it is an important question as well. So there are four options. First, null risk, B, null safety, C, null pointer, and D, all of the above. It is a very important question, and now the correct option of this question is E, null safety. Null safety allows us to remove the risk of occurrence of null pointer exception. It is a very essential feature of Kotlin language. Now, moving on to the seventh question, which is what is null safety and nullable types in Kotlin? So, null safety, commonly referred to as void safety, ensures that no object references have null or void values. Whereas in Kotlin, nullable types are references types that are declared by appending a question mark to the string. This question mark is what we add at the end of the data type to make it as nullable. Now, moving on to the eighth question, which is what is higher order function in Kotlin? A higher order function accepts one or more functions as arguments and returns a function as output. It is not like any other function. The higher order functions are frequently combined with Lambda expression to create code that is both compact and powerful. Instead of integer, string, or array as a parameter to the function, we will pass anonymous function or lambdas in higher order function. So basically, we pass a function to other function known as higher order function. Now, moving on to the ninth question, which is what is Lzf operator? The null safety attribute in Kotlin allows us to assign null values to the variables. We can use if else or the Lzf operator to see if a value has a null value. Lzf operator returns the first operand, and if that operand is true, otherwise evaluates and returns the other operand. Now our next question is, why is Kotlin interoperable with Java? So this is our 10th question. So Kotlin is compatible with Java because it uses JVM bytecode. JetBrains places a strong emphasis on Kotlin's interaction with existing Java code while building compatibility. The team ensures that Kotlin can interface with existing Java code easily and thoroughly. Compiling it directly to bytecode speeds up the compilation process and eliminates the distinction between Java and Kotlin on JVM. So this is the reason Kotlin is interoperable with Java. Now coming on to the 11th question, which is, what are the range expressions? A range is a set of values defined by their beginning and ending points. Range expression in Kotlin make it easier to iterate over a set of values. To make a range in Kotlin, use the range to and down to functions. We may also define a range of values by using the double dots operator. As we can see in the example, for I in 1 double dot 10. This will print all the elements from 1 to 10. And for 10 in down to 1 will print all the elements from 10 to 1 in descending order. The third one is, which is for I in 1 double dot 10 step 2. This will print elements with a gap. Now step 2 means there's a gap. So it will print elements like 1, 3, 5, 7, 9. Because we have used step 2. If we'll use step 3, then it will give a gap of 2. Like 1, 4, like that. So on. Moving on to the 12th question, which is, what do you understand by data class? So data classes are the classes that are used to hold the data or information. These data classes were previously exclusively used to generate Java codes. But with the explicit implementation of the higher and greater collection of properties, they are now important in Kotlin as well. Functions like toString and equals are also combined with this language. Now, moving on to the 13th question, which is immutable variable. So this is a multiple choice question, and the options are A, variable that can be changed, B, a variable that cannot change, that is read only, C, a variable used for string interpolation, D, none of the above. So we have already talked about immutable variable, and you can pick the correct option. Now I'm gonna say the correct option. So the correct option is B. A variable that cannot be changed is called immutable variable. That is the variable that cannot be changed. Now coming on to the 14th question, which is, what are coroutines? It is a very important concept. So the letters co and routine stand for cooperation and function respectively. A coroutine is a Kotlin feature that can perform everything a thread can do while still be incredibly efficient. A coroutine is a lightweight code that doesn't require any processor background switching and doesn't map on native threads. So this is coroutines. Now let's have a look at the 15th question, which is difference between safe calls and null check. Safe call operator is used to determine whether a variable's value is null or not. If it is null, null will be returned. Otherwise, the requested value will be returned. On the other hand, when the value of the variable is null, you can use the null check operator to throw a null pointer exception. So this is the difference between safe call and null check. Now coming to the 16th question, which is, what are init blocks in Kotlin? Initializer blocks that are invoked after the primary constructor are known as init blocks. One or more init blocks can be found in a class file, and they will be run in order. In Kotlin, it is not feasible to do any operations in the primary constructor. Instead, you must utilize the init block. So this is the init blocks in Kotlin. Now our next question, which is the 17th question, is what are lambda's expression? So lambda's expression are anonymous function that can be handled as values, meaning they can be sent as arguments to a function, returned or used in any other way that a normal object can be used. So it can be returned and used in any other way like a normal object can be used. So the lambda expression has no name and is created and assigned as a separate variable. It doesn't have any parameters and returns no value in the function. So this is called lambda function. It is used with higher order functions. Now coming to the next question, which is what is inline function? So inline functions tell the compiler to include the entire body of the function wherever it is called in the code. It is used to improve the performance of higher order function as well as the inline function call and inform the compiler to copy parameters and functions. To use an inline function, all you have to do is to add the inline keyword to the beginning of the function definition. So this is inline function. Now coming to what is null safety. So null safety is a very important feature. The type system of Kotlin is designed to eliminate the risk of null references in code. The type system in Kotlin distinguishes between the reference that can and cannot hold null. So here's an example of not null reference which will show you compiler error. So this is the example, string equals ABC. After that, the other is the example of null reference where we have used the question mark as we have discussed previously. So because to allow a variable to hold null, we have to declare a variable as nullable string with question mark. So now our next question, that is the 20th question, is what is late init? So late init is an abbreviation for late initialization. If you don't want to initialize a variable in the constructor and instead want to do it later, and you can guarantee the initialization before using it, use the late init keyword to declare that variable. It won't start allocating memory until it's been initialized. Now our 21st question is what is the difference between const and val? The const keyword is used to declare properties that are immutable by nature. That is, the properties that are read-only. Also, the values of these properties must be known at compile time only. Now, if we talk about val, for read-only properties, the val keyword is also used. But the main difference between the const and val is that the val properties can be initialized at the runtime also. But it is not so in case of const. Coming to the 22nd question, which is what is the difference between open and public? So open for extension is what the open keyword indicates. The open annotation on a class is the polar opposite of the final annotation in Java. It allows others to inherit from it. On the other hand, if no visibility modifier is specified, public is used by default, which means your declaration will be visible everywhere. If nothing else is supplied, public is used by default. So next question is, what defines a sealed class in Kotlin? So it is a multiple choice question. A, it's another name for abstract class. B, it represents restricted class hierarchies. C, it is used in every Kotlin program. D, none of the above. So the correct option is option B. It represents restricted class hierarchies. So the restricted class hierarchies defines the sealed class in Kotlin. Now moving on to the 24th question, which is what is lazy initialization in Kotlin? So lazy initialization is a feature in Kotlin that indicates that your variable will not be initialized unless you utilize it in your code. If it only be initialized once, after that you repeat the process with the same value. So now moving on to our 25th question,
which is what is the entry point of every Kotlin program? Every Kotlin program's entry point is the main function. The main function does not have to be written inside the class in Kotlin. The JVM automatically encapsulates it in a class when it is compiled. The command line arguments are retrieved using the strings given in the form of array string. So this was the answer of this question. Now moving on to the next question, which is what are companion objects in Kotlin? So if we wish to write a function or a member of a class that may be called without needing the class instance, we can do so as a member of companion object within the class in Kotlin. As a result, by declaring the companion object, we can only access the class member by a class name. So this was the answer of companion objects in Kotlin. Now moving on to the 27th question, which is where does this Kotlin run? So Kotlin programs can execute on a normal JVM just like any other compiled Java code. This means that the Kotlin compiler converts Kotlin programs to bytecode that the JVM can understand. As a result, Kotlin is a Java kind that works alongside with Java. So basically Kotlin is a kind of Java, you can say that. It is worth noting that bits of Java code can be used to create Kotlin applications. So now our next question is, why do we need object keyword? The object keyword in Kotlin allows you to declare a class and create an instance of it in one step. The object keyword is used to obtain a data type with a single implementation. It has three different meanings and can be used in three different contexts. First is object declaration, object expression, and companion object. So this was the meaning or why we need object keyword in Kotlin. So now coming to the second last question, which is what is string interpolation? So let's start with the launch. So launch is a coroutine that fires and then forgets. It's as though a new topic that has been started. If the code inside the launch throws an exception, it's considered like an uncaught exception in a thread, which is normally written to stderr in backend JVM apps and crashes Android apps. Now on the other hand, async. Async is used to launch a coroutine that calculates some data. You must use a wait on the result, which is represented by an instance of dereferred. Uncaught exceptions in async code are held in the resultant dereferred and are not transmitted anywhere else. Unless processed, they are silently dropped. So, although async is used to start the coroutines, it does so by blocking the main thread at the await function's entry point. And launch will not block the main thread, but the rest of the code will not be executed while waiting for the launch result because launch is not a suspend call. And this was the last question, that is the 30th question of Kotlin interview questions.
Now, with that, we have come to an end of this Java and Kotlin programming tutorial. I hope the session was interesting and informative. If you have any queries regarding any of the concepts covered in this session, or if you require the resources that we used in this session, like PPT, code, etc., then please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.